How do I know that the rockets can't enter into this medium? Because we've seen rockets attempt to enter into this medium with no success.
How do you know they entered the new medium?
They didn't enter the new medium. They can't.
How do you know they tried?
We've watched rockets go up.
Okay.
And they come
How
back
do you
down.
know they didn't stop somewhere in the air? How do you know they were at the boundary between the air and this other thing?
Have you seen the go fast?
Probably.
Yeah, so
I
that
don't know by
rocket goes
name,
up,
but...
hits the other medium, stops, comes back down.
It didn't show it hit anything. That was an assumption.
Yeah, I don't recall it hitting anything.
Well, you'll have to go look at it.
No, Kimo, one thing I haven't heard, right, is your explanation for why you take a bag of chips or a bag of crisps.
And
to
it
mount
starts to expand and stuff, yeah?
I've never really heard your explanation for that.
Just a temperature variation, temperature difference, really. Yeah?
It gets colder as you go up, right?
Yeah,
so
if
it gets colder as you go up, then technically...
Yeah, but you got all that high temperature inside, right?
Put a bag of chips in the freezer.
Yeah, so you got all that high temperature inside trying to go to the low temperature.
Right, well, if you just let it sit for a little while, the temperature would equalize.
Will equalize, yeah, that's right. But as
just
it
the
goes
same
up
way as if you put a bag of chips, if you put a bag of chips in the freezer,
yeah,
right, it will equalize in temperature, and eventually you'll see it get smaller, right, as far as the overall volume of the bag of chips goes.
Yeah, but
now,
I mean, initially,
it on a mountain, you leave it up on the mountain, you let it equalize. It won't get smaller, will it?
No, initially it will expand and then collapse.
It doesn't collapse though. We don't see the. If you go to a store,
no, in a freezer.
If you go to a store up on a mountain, right? Let's say you go to a ski lodge, and they're selling chips. Those chips they've had enough time to equalize in pressure and temperature. They're still very puffy compared to down on sea level.
Yeah, but if you think about a balloon, there's all that high temperature inside compared to the lower temperature outside.
But if you've had those chips sitting in the ski lodge for fucking a month, it would have equalized in temperature by now.
Again, where does the pressure come from, Emerald?
The gas pushing on things?
The gas pushing on things?
Well, yeah, it is gas pressure, no? That is the pressure caused by the gas.
Yeah. But where does the acceleration come from?
When it collides with things. Same with any kind of collision, there's an impulse.
What does it collide with?
Depends. If it hits another gas particle, then that gas particle. If it hits a wall, that wall. If it hits a barometer, that barometer.
No, the gas molecules are not bonded. They move freely.
Yeah, they're not bonded, but they can hit things.
They
Just
can't,
like I can
they
throw.
can't
I mean,
bond in the way you're describing, where they bounce off each other.
I'm not describing bonding. Collisions are not bonding. If I have a ball pit, none of those balls are bonded to each other.
They don't bounce
they can
off
still...
one another. Yeah.
Emerald, I'll tell you this, Emerald. Right? Look.
Yeah.
Trying to explain stuff like pressure in a flat Earth conversation using particles and particles in.
Yeah, that was my first leap of faith, and it seems like Chemo's at least partially on board.
But look, just explain where the pressure comes from, because you've said colliding particles. Can you demonstrate colliding particles are producing pressure?
Yeah, it's Brownian motion.
Go on then, give us a look.
Yeah, look up Brownian motion.
Is that in a container?
Doesn't have to be. You can just have it on a plate.
So there's a surface?
Sure. But it's not the motion on the surface, it's motion.
Well, do it without
laterally.
the plate then, and let's have a look. Oh, you can't. Not possible. Yes?
I'm thinking about if there is a demonstration I can think of.
Oh,
that
don't you
has
start
no surface.
promising things. We've already had a ball Earth of promising things that they can't do.
Didn't promise, I said I'm thinking about it.
I wouldn't even bother. Accept it.
See, you don't want me. You just want me to accept it without thinking.
Well, I'm giving you advice. You're wasting your time.
Hey, Emo, how come all the gas seems to be lying at the bottom of this so-called flat Earth container?
The gas is there because it's produced at ground level.
But isn't it also absorbed at ground level?
Is it only if the temperature drops and then it's
And you totally missed the point. Why isn't it rushing to fill the container?
What? Sorry.
Why isn't it
I
rushing
don't
to
think-
fill the container?
Why isn't what filling the container? The gas.
All the gas that's lying at the bottom of your apparent flat Earth container. Why isn't it rushing to fill the container?
We're not
like
in
the
a
climate should?
container. We're not in a container.
Yep. Chemo's the exception.
I didn't say we're in a container. You can ask the flat earthers to show you the container.
The question's still relevant, though, isn't it, Chemo? Why is all the gas seem to be down here?
Temperature. If it's colder gases, they become more dense, and then they will fall.
What about the thermosphere?
Thermosphere. That up in the sky somewhere, yeah.
Yeah.
Well, I mean, again, that's just part of your narrative, not yet to be proven.
Got it. So, where do you say that this new medium starts?
Medium news would start where the rockets can't go, yeah.
I'd expect a number. And
I'd
is
have to be
that
guessing.
altitude the same?
No, I'd have
across
to
the Earth?
double check and look. I'd just be guessing. But there is a
All
height.
right. Feel free to do that then. Double check and let me know.
Oh, I mean, just look up Operation. Oh.
Oh God.
A lot of these things were done before you were born. You know, if they did try to do it now, we'd ask more questions. Back then, they weren't as curious. They
They
just
do it now.
If I look up Operation Fishbowl, will I find a measurement or a
they'll tell you
reported
how
value
just
of
type
how
in,
high that new?
Yeah, just tell how high rockets were being fired up into the sky. Sure. But you still haven't answered where the pressure comes from. Okay.
Oh yeah, we were in the middle of that discussion. So yeah,
That's right. Yeah.
particles don't have to be bonded to collide with each other.
Yeah, but there's no pressure when they do collide. If you think they do,
What happens when two objects collide?
but they're not solid spherical spheres for them to collide. Pressure.
They are matter, no?
Yes, but the pressure in your world comes from gravity, as in pulling the atmosphere down. With gas pressure, it comes from the walls of the container. And that's why a lot of flat earthers are like, you can't have gas pressure without a container, because they think the atmosphere is pressurized. But obviously we know when, well, not everyone knows, but I know when you pressurize a gas...
No, the gas pressure doesn't come from the walls of the container. It's manifested at the walls of the container, but it's not the walls of the container creating the pressure.
You can measure the pressure on the walls of the container if you want. You could also put a barometer far away from any of the walls, and it'll still measure that
No,
pressure.
but, Paul, that's where the acceleration comes from. It hits the walls, accelerates, hits into the walls.
No,
accelerates.
this is a misconception, Chemo. This is a misconception of most flat earthers, thinking that the walls of the container create the pressure. They don't.
That's the definition. You can't just change the definition.
Well, actually, it's not that's not the definition of gas pressure. That's how you measure gas pressure. The actual definition of gas pressure involves momentum flux through a unit area anywhere within the medium.
No. You don't know more about pressure than me, Paul.
Yeah, I probably do.
I think that is exactly what we're about to reveal.
No. When it comes to pressure, atmospheric pressure, you need a force, or you need a container.
You're about to say you need a container, weren't you?
Well, for the gas pressure, yeah.
Well, yeah. What happens when two objects collide?
Well, gas is not an object like a spherical object, like that.
Gases do consist of particles, right? Molecules of whatever gas that is.
Well, again, you
You're
can't.
moving.
And as particles of matter, they can't be in the same place at the same time, so they don't just phase through each other.
All you got to do is explain where the pressure comes from. It's not hard.
Yeah, we're getting there. As soon as we establish some simple facts, such as when gas particles, which are matter and can't be in the same place at the same time, get close to each other, they bounce off each other because they physically can't just go through each other.
Yes,
And when they do that,
that's what would
they change in
happen.
momentum. A change in momentum over time is by definition a force. And a
But look-
force over a given area is by definition pressure. So collisions of gas particles is sufficient to create gas pressure.
No, and that's what you don't get gas pressure in that way. You get gas pressure.
You do.
Well, can you
It
demonstrate
is
that?
literally, it's not even a
More
logical
particle,
step. It is
more
literally
pressure.
just the definitions of these terms that gas pressure is manifested when those particles collide.
No, that's not true. You're just making. Show me the definition where that says that.
Chemo, stop it, dude. You're doing the same shit.
I just go around making up definitions.
Yeah, but you can't just go around fucking asking for words to be defined. You're pulling a fucking Riley, bro.
Well, if we're talking about gas pressure,
Quote, gas pressure is caused by the force exerted by gas molecules colliding with the surfaces of objects. This includes objects like the gas particles. Although the force of each collision is very small, any surface of appreciable area experiences a large number of collisions in a short time, which can result in a high pressure.
what, is that
There you are,
atmosphere?
Chemo.
Is that
Yes,
gas or
Is
atmospheric
what you should
pressure?
have said.
The
Yes,
atmosphere is made of gas.
No, why are you talking about gas pressure or atmospheric pressure?
This is gas pressure. Those were the first two words of my explanation.
The gas pressure. So what is atmospheric pressure?
The pressure of the
No.
atmosphere, which is gas
Bro,
pressure.
stop pulling a Riley, Chemo. Trying to confuse him by asking him for definitions over and over and over.
It's not confusing. It's the atmosphere consists of gases.
I know, but that's what he's trying to do, bro.
Atmosphere gas molecules at 20 C 14 move at 300 to 400 meters a second.
He's gonna keep asking for
Interesting, really?
definitions until
That's
he
pretty
feels
fast.
like he's won the conversation.
What was that? I missed that bit. What were you talking about? Gas molecules moving at how much?
Apparently 300 to 400 meters a second. Interesting.
Wow, that's very
I'll double
fast.
check that.
But not fast enough.
That sounds
for the
exceedingly
atmosphere.
quick, but I don't know, I
But
have to think about that more.
they must lose some momentum as they reach the upper atmosphere. That's why we've got
They fall back down.
different gas pressures at different altitudes.
I guess if that's the speed of sound. Air escaping. Yeah, that makes sense then. 3 or 4 to 3 meters per second is the speed of sound.
Gas moves at a different
yeah.
speed.
Yeah, okay. That makes sense. I'll
And presumably
Double
that's
check
at
that
a
as well.
certain temperature. I mean, possibly
yeah,
when it's
that's
colder.
at STP.
What's that? ST what?
Yeah, standard temperature and pressure. So it's basically
Right,
sea
okay.
level at, I think 20 C is the standard.
Right. Okay. Yeah. Fine.
But yeah, if you've got trillions or quadrillions or even more of these particles, and they're moving at that speed around the surface, they're gonna eventually hit each other. Or any surface you bring in. Like even if we grant you, Chemo, that these particles aren't colliding with each other, at the very least, if I stick a surface amidst all that gas, those particles are gonna hit that surface because it's got some appreciable area, and when they do, they're gonna press upon it. So just the collisions of gas particles with any surface introduces pressure on that surface. It doesn't have to be the edge of a container. It just has to be anything you're introducing into a sea of gas.
Oh, this container is a flat Earth trope, just trying to pin you into some sort of silly
It
little
is.
box.
Chemo is an
I'm afraid.
exception in that he doesn't think there is a container. But even amidst that, the question was asked, where do you get the pressure from? And the answer is simply from collisions of gas particles with surfaces.
Yeah, that's jolly good to know.
I mean, the walls of the container are surfaces, so gas pressure does manifest there, but those aren't the only surfaces. For example, the ground is also a surface, and as such, it experiences gas pressure. This is why if you
Yeah.
decrease the pressure around water, it starts to boil, because as there's less and less pressure holding the water there, it can boil away.
Oh, of course. Yeah. Now I see it. Yeah. That's That
And the
answers
higher
a few
your
questions
attitude,
for
the harder it
me.
is to
knowing that.
boil.
Does that make sense, Chemo?
Alright, sorry about that. Where are we now? So look, again, you've got two definitions. You've got the
I'm listening
walls
at all.
of the
You see, he
container.
doesn't listen to people in the slightest. All he's interested in is his own little script.
No, we're only interested in what we can validate and verify. Now,
Yeah.
atmospheric pressure
We can
requires-
validate that any surface we place within the midst of a gas field will feel the pressure upon it, as evidenced by the fact that barometers measure pressure regardless of where you
No,
are.
no, but we're talking about the atmosphere. Where does that pressure
Yeah.
come from?
What is the atmosphere made of, Chemo?
The atmosphere is cold. It's made of gas.
There you go.
Yeah.
And where does gas
Not-
pressure
not-
come
not-
from, Chemo?
Yeah, but the atmospheric pressure comes
Where does
from
gas pressure come from, Chemo? Answer the
Yeah.
question.
gas
the
pressure comes
measure
from
the
walls
measure of
the
atmospheric pressure is how much gas pressure the atmosphere is exerting
Yeah, that's through gravity.
You can use gravity to figure out how much there is, because it turns out that they're related.
No, because the atmosphere is not flying off into space, right? So it's being
Correct.
pulled down by gravity. It's being held down
Correct.
by gravity, yeah?
Correct.
That's where the pressure comes from. It's being pulled, pressed down by gravity, which stops it from flying off into space. Got it?
That keeps it from flying off into space, but the pure fact of those gas particles that are stuck near the Earth colliding with surfaces is what causes the pressure.
No, we're talking about atmospheric pressure.
Yep, I'm aware,
and
and that's exactly what I
You're
responded
saying
to.
the molecules bouncing off one another stop it from flying off into space?
No,
No.
it doesn't even have to be one another. I conceded that. Let's
It's
say
not
that's
enough.
not even the case.
So what
for
stops the
purpose
gas
of
from flying
argument.
off into space?
You already answered
The
that.
gas doesn't have enough speed to get that high. It's going to get to that point and then go, nope, I can't make it. Nothing else to hit against. I'm falling back down the ground.
Yeah, like we don't even have to. We don't even have to invoke any specific, form of gravity here. We can just
what
use
was
the
the
fact
reason?
that.
Why you didn't give me the answer? Why doesn't the gas go off into space?
Were you
Remember he
here
said
when we were talking
300
about our
miles an hour?
discussion of escape
No, I was just on
velocity
the
earlier?
phone.
No, he's not prepared to acknowledge any information that doesn't go outside his rather
Okay,
limited.
so Chemo, let's build up to this. If I throw a baseball upward, we acknowledge that it will not fly out forever, right? It will eventually come back because it's not fast enough, right?
Okay, yeah.
Someone in the chat said that gas molecules at standard temperature and pressure move at like 300 to 400 meters per second. That's still not fast enough for. I mean, bullets move faster than that. But if you fire a bullet upward, it will eventually come back down. So these gas molecules are not moving any faster than even a bullet. Yet a bullet comes down. These gas particles are also, when they go up, eventually going to come back down. They're just not fast enough to leave.
But
Yeah,
you
do you
We don't
know
have to
understand
invoke any kind of
there's a
special
vacuum
pleading
of
about
space.
gravity at all.
You
We
understand
just
there's
have to
you know-
know that.
You understand there's a vacuum
know-
of space next to this atmosphere.
Do you know in these
Nope.
foreign countries when people shoot
There's
up
no
into the
vacuum
air
of
for their
space, Admiral.
celebrations? Chemo, you're talking over me. You know in these foreign countries when people shoot their bullets into the air for their celebrations, lots of
Yeah, like
people
Texas.
die when the bullets come down.
Does that make sense, Chemo? If bullets can't make it out of the atmosphere, neither can gas, which moves like 3 times slower.
Yes, but I'm not saying to you there is a vacuum above that gas. Why doesn't it fill that space?
It's not fast enough to fill it all.
It doesn't need a speed. Why doesn't it fill the space? That's what we see in nature.
It has no reason to fill that space.
Wow.
I mean, it has no reason to fill the space.
If you can't
Yeah,
get to
if
the
the
area,
gas, if there's a force that is pulling that gas toward the Earth,
Ah, we got
And-
there eventually. What is that force?
Yeah, that was painful, Chemo. Well done, Bill.
Goodness
got him to
sake.
say it
Yeah, it's like
finally.
pulling teeth with you, Globus.
all the other atmospheres on top of it.
it doesn't even matter what it is. In fact, I'll correct myself and say it accelerates toward the Earth, and
No,
that's
no, you said
observable of
there's a
any object,
force.
regardless of the underlying cause.
What is that force?
It could be whatever you want to call it.
I don't know. You tell me. What is it?
No,
Name-
you tell
names-
us, Chemo.
Whatever. Let's call it the force of returning to Earth.
The force
To
of
use a
returning
verbose
to
term.
Earth.
Yeah,
The
that's
force
a
of
good,
returning
that's a
to
good way
Earth
of putting it.
blocks the gases from going into space.
Yep, just
That's
as it
what I
blocks
said.
every other object that we throw upward.
Okay, how do we test for this force of non-return or return?
Take any object, pick your favorite. Actually, don't pick your favorite because you might smash it if it's fragile.
Mhm.
Pick your least favorite object.
Yep.
Throw it upward, and then observe the clear and obvious consequence that it will not continue going upward forever.
Okay, so I took my basketball, I went under water, I threw it up, and it kept going up. So you failed. Your
And then it got
hypothesis,
to the
What?
surface of the
your
water and promptly
hypothesis
stopped going up.
failed.
And then it got to the surface of the water and promptly stopped going up.
Yeah, but I was at the
So,
surface of the ground underwater, where you
That's
said
not
stand,
atmosphere,
drop
is it?
your object.
That's
I
not what
dropped
I
the
said.
basketball.
I said it will not continue going up forever. Your ball eventually gets to the surface and eventually stops going up. So I'm right.
No, but the air inside it,
Doesn't
when it was
drop back
popped.
down, though.
Go ahead. Right.
Yeah, it doesn't drop back down, right? There isn't a unique, only downward bias to the nature of creation. some things move up and some things
But
go
you know
down.
what it does return to? It returns to the bottom of the atmosphere.
Yeah, but what if I put more water underneath that ball? Will it keep going up? Not down, like you said.
It'll go up until the point where your water overflows.
So
You'd have to raise the surface.
cause then
You'd
is
have
the
to raise the
water.
surface level of water across the entire Earth.
Well,
to
where's
get
this force then that you're talking about?
Because if you don't,
then?
your water is going to keep.
So I changed the medium and got a different effect.
Yeah.
Yeah.
Buoyancy
So
also has an effect on objects' motion.
let's see you use
This is-
gravity and make the object go back up.
Gravity and make the object go back up.
I'm asking you to use your force, your cause, to make the ball go back up without changing
Why are we
the
talking about a
medium.
ball going back up when we were talking about the atmosphere staying down?
Because you just
talking
said
about
drop an
opposite things now,
object
Kimo.
and the object will prove a force. And I'm saying, well, if I change the medium, it goes up against your hypothesis.
Well, yeah.
Yeah,
And that's
so
why we
you're
were talking
wrong. Your
about the
hypothesis
atmosphere.
is incorrect. You did another
We
hypothesis.
were talking about the atmosphere, and now you're changing the medium.
So what's the cause
you're
then?
talking about
If
something
we've
different
established it's not a force, when I drop the object, what's causing the atmosphere to stay on the Earth and not go into space?
I've already told you.
And we've
Just
just
like
been
any other
through your
object.
hypothesis, and it failed.
The light,
Except that it doesn't.
lighter pressure would be replaced by the lower pressure. There's a hotter below. We're going to push up and push the higher.
Chemo, what you're doing in your experiment is failing to isolate variables. You've introduced a new variable, which is the medium, and then you're complaining that the experiment doesn't work.
That
That's
variable
obvious.
is my independent variable, is my cause.
No, why are you changing the cause then?
Because you said you have a cause, and I'm saying, well, I have a different cause. Let's test our causes. You haven't tested your
gracious.
cause to make the object go back up. I can make the object go up. You can't. Why?
Heat makes the object go back up. As far as air. Or
Make the
as gas.
basketball go up and down with gravity.
No, it's gas. We're talking about gas and oxygen and atmosphere. Heat will cause.
Yeah.
With
Let
water,
me
I can change
let
the
me try to make
direction.
this easier for you. Let me
Okay.
simplify.
Okay.
In the absence of influence by other things like buoyancy, any object on or above Earth with sufficiently low speed will be accelerated toward the Earth.
Buoyancy is gravity, right? It's the opposite of gravity.
Buoyancy
No,
often,
it's a
often
result
acts
of gravity.
Right, so
often
it's
acts
connected to
in the
gravity.
opposite direction
yeah?
of-
You can't have buoyancy without gravity, right?
Relative density is called specific gravity weight to displace water.
Can you have
Yes,
buoyancy
correct.
without gravity?
Can you have
No.
buoyancy without gravity?
Yeah.
I don't know.
No.
You can, but you need some other force acting. It might not be gravity, but you do need a force acting to have buoyancy.
There you go.
Yeah,
we
so what you
can't-
need-
we can't, we can't prove that force. You can't invoke buoyancy.
What?
We're trying to
do you
establish
mean?
when you drop an object,
You find
Emerald, your hypothesis was there was a force pulling it down, and I said, well, I did what you said underwater, and it went straight up.
No, but you didn't drop something down.
Yeah, you didn't drop it. You released it underwater.
let it go,
You changed
yeah.
the medium.
I let it go, and it fell up.
Yeah, we were talking about the atmosphere, and now
Fell
you're
up.
deflecting to underwater.
That medium, you mean, that we're in, the atmosphere. But in this medium, things go that way. In a different medium, it goes that way. What's your point?
Yeah, it shows that medium can also affect objects' motion.
Yeah,
Congratulations.
we know this. This is what we've been telling you.
Yeah,
Yeah.
we know that. We already know that buoyancy can affect objects' motion. This is what the egg
Buoyancy?
experiment did.
Buoyancy is gravity. Can't have one without the other.
No, buoyancy is
Yeah,
not
you can.
gravity. Buoyancy is a result of gravity. It isn't gravity.
Yeah.
Buoyancy is just a force that a medium places on an object due to a difference in pressure.
Yeah, and
You can
gravity.
generate buoyancy in, like, this is what centrifuges do. They spin things around to artificially create a pressure gradient in whatever the thing you're spinning is, and that causes less dense objects to buoyantly float to the top of the vial.
But
That
you need
no
you
gravity
need
required for a
gravity
centrifuge. They use
buoyancy, right?
centrifuges everywhere.
Yeah, we know.
So, no, you don't know, because you'd already said earlier that buoyancy is gravity. That's wrong.
So we agree then, if you change the medium, we change the direction.
Yes, that's obvious.
Obvious, yeah. So there is no pulling force that's pulling things to the center.
How do you get that?
We've just established we can change the direction, pull things up and down.
How did you establish it? Did you
Yeah.
establish that? Did you establish that by changing the medium and removing the force?
What force? There isn't a force to manipulate.
Chemo, you do realize that effects can have more than one cause, right? Like if I throw a ball or if I launch it from a cannon, they'll both cause the object to move.
Not in the
But just because I
natural
threw a
physical
ball
world,
doesn't
no.
disprove that cannons exist.
No. There's only one cause when it comes to natural science.
Oh, so you have that misconception. Got it. This is gonna make this a lot
Yeah.
more difficult.
Yeah, chemo, that's wrong.
Yeah, Chemo, that's not true.
Oh, dear.
Well, go on then, give me an
there's-
example. Enlighten me.
Post it in the chat.
If I have a bouncy ball and it just casually rolls off my table, it will fall. If I pick up that ball and drop it, it will also fall. So falling is caused by two things.
This is like the basis of Zanek's scientific acumen test that he gives flat earthers. He wants you to know that.
Well, yeah, it's a litmus test that I didn't expect Chemo to fail. I'll be honest,
Yeah.
I was actually expecting you not to have this misconception. I dealt with someone else earlier who had the same problem back in Betty's server. By golly, that was frustrating.
Well,
But
when
you
it
do
comes-
see how that's wrong, right, Chemo?
No. Of course, when it comes to the natural physical world, there is only one cause to any given.
Says who? I just gave you a counterexample, so is that not reality?
That's the scientific.
Scientific method says there's only one cause.
The effect. Yeah.
Can you cite that? I mean, I recall that the scientific method says you can prove that some cause causes an effect. It doesn't mean it doesn't say anywhere that it excludes other causes.
Yeah, there could be multiple layers here.
Yeah.
You know, that
The only mention of excluding other possibilities is by isolating them. So
I'm
if you
asking
didn't
for an
isolate for other
example.
forces,
You haven't given me an example yet. Nobody.
Well, hey, chemo. That's why the null is there. That way you can find if you do an experiment and you get a result that doesn't align with your hypothesis, you get a null result. Now you're looking for a different cause, because as you fleshed out through experimentation, you determined that your original cause and effect were not exactly a correlation.
Exactly.
So then you
it's
go
not
through.
Precisely, it's not a cause.
Yeah, it wouldn't be your cause, but it caused your. It was in your naturally observed phenomenon. You did see that happen, but when you fleshed it
Hold on,
out,
quick. Hold on.
okay.
So when you see something, you are hypothesizing cause. So you could get it wrong. We could say sun curvature. So we hypothesize it's the curve. That's the cause of the ships or the sun disappearing bottom first. We could say that. But that's wrong. That's not the cause. Right?
but Chemo,
Right.
you're
Yeah,
aware of the
you got
ideal
it.
gas law, right? PV equals NRT.
Yeah,
Yeah,
sure.
hold on, Emma, real quick. Yeah,
Yeah,
you
go
got
ahead.
the chemo. Okay, so basically what it's saying here is that if you've got causes and effects, okay, there could be other things happening besides just the one. So that the example you said would be like the atmospheric refraction or atmospheric lensing. That's what you really want to determine what the cause was, not the shape of the Earth.
Hey, Chemo. No, one thing that we need to do though, Chemo, can you define cause and effect?
But he's got the right, but he was. I
We
think
need a definition.
yeah, he skidded the grease on the wheels.
Yeah, but unless we get a definition, I don't see how this conversation can go forward. Chemo, please define to me what you mean by cause and effect.
Well, it's the principle of causation. We're talking about a relationship too, so they have to be connected one way or another. So if we have an effect, it's caused by an independent cause. Quite
How do
simple.
you verify that the cause was actually the effect?
No, the cause to the effect. Yes. So how we verify the
How do you verify if the cause was the effect?
by varying and manipulating your independent variable, which will.
But how do you know it wasn't something else that you weren't controlling for?
Well, that's the point. You would, if you
Yeah.
think it's something else.
In your basketball experiment, you weren't controlling for other forces because you were changing the medium around.
No, but the idea is if you think it's something, you think it's fairies, you're going to have to test for fairies.
Let's go with that little story. If you had a basketball that you could take in the water, and if you hold it down, and it's going to be underwater until you let go. If you take it further down, it's going to be ripped out of your hands. Why?
The medium. But But look, the point is that the cause and effect, what we're looking for.
Yeah.
And unless
I've already given you an
manipulate
example,
that
like-
independent variable, we're not going to
Density.
actually know what is the cause. So that we're looking for a relationship. Yes.
Okay, so what
Sure.
you're basically trying to say,
But,
Kimo,
like-
is that cause doesn't necessarily have to be the effect.
Cause is not the effect. No.
Okay, so what is it?
What is what?
What's the difference?
One is the effect, and the other is the cause.
How do you
Amazing.
distinguish the relationship between the two?
Well, first of all, you would have an observed phenomenon that is questionable, an effect, effectively, and then you would hypothesize what has caused what you have just.
How do you know they were actually related and there wasn't something else that caused the actual relation?
Because you would hypothesize, and if it agrees with experiment, you are correct.
Even
Branch is
hypothesize,
right. Branch is
how do
right.
you know
Maybe be both.
a relation
Hey.
between the two?
How do you confirm your hypothesis? How do you know that what you've done is correct?
Well, that's just it. You don't know until you manipulate your independent variable.
I mean, I could hypothesize
Mhm.
that the higher up you run up a hill, the more tired you get.
That's not
The
science.
reason for it could be because you've just been running longer.
Not science.
Or the reason for it could be
That's not
that the air.
science.
I don't know which one.
This is not science.
In
What
what
is-
way is it not?
What is science?
That is not observed phenomenon.
What if I observe animals going uphill and some of them get tired and
Still
something?
not an observed phenomenon.
It's observing something happening in nature.
Still no cause and effect relationship.
Your
I can
opinion.
hypothesize that the cause for that is the height they go up the hill.
Do whatever you like, but it's not science.
Well,
Give us
it
an
fits your
example of
definition.
science.
Your
So.
redefinition
So
of
a
science.
fantastic example of
Give
science.
us an example of an observed natural phenomenon that you
There
can
are
apply
two
your scientific
fantastic-
method to.
Yeah, there are two fantastic examples. We have the sun disappearing the way it does. Is it going over curvature? Is it going under the earth? What's going on here? This is very, very curious and very questionable. So that would need explaining with science, force to this effect. And also dropping things falling like the apple.
Let's go with the sun one first. Look at one of them.
Let's do the sun. Let's go with the sun first.
Absolutely.
So how do you do your science on the sun?
Obviously,
So-
you
What are your
have-
variables that you're controlling?
You go out, you see the sun disappear, you say, wow, that's got to be the curvature. It's disappearing bottom first. Half of the sun. Hypothesize curvature. Then now you've got to go out and test, see if the Earth is actually curving. Find out that it's not curving, so you rule that out. It's not because of curvature.
Chemo,
How do you
okay.
how do you manipulate the curvature, Chemo?
And
What are your
so
variables there?
What
when
you're doing is you're looking
for the
so how you manipulate the curvature is on a globe you expect the physical geometrical horizon to be in its location continuously.
But how could you know that?
Because if you know the
have to
size,
stop it.
if we in our hypothesis, if we say, if I presuppose the Earth is this size, based on these triangles, based on these shadows, the Earth will have this radius. Now, if I'm this height and I look out this far, the horizon should be there, basically, essentially.
Hypothesis, a statement. That's a statement. That's not a hypothesis.
No, that's all in my heart. This is all I'm thinking. I'm thinking this. Now I need to go out there.
It's not a hypothesis.
I need to be able to
Don't even
manipulate.
know what it is.
I need to be able to manipulate my
can you
independent
imagine?
variable, which is
Can you
the
imagine you write a PhD statement, right? Or your hypothesis or PhD is exactly what you just said. Can you imagine someone doing that? Oh, because it's absolute bullshit.
So
Be a
we'd
real
have to,
hypothesis, Chemo. Okay, Chemo, you know
Can,
what
can
we
you
need to do?
restate?
You know
Hang
what?
on.
In order for this conversation to move forward, Chemo, I need you to define to me hypothesis means.
Well, first of all, we need to find out if the Earth is curving. We figure out it's not
Oh,
curving.
first-
That's
rule
not
it
an
out.
answer to his question.
First of all,
Yeah, we-
Timo, we need
We
to
need
define what
clarification on what a hypothesis is.
Goodness sake. So that is your predicted cause. You hypothesize your predicted cause. Yes?
It's a
Give me
good
the-
guess, is it?
Makes no fucking sense, Kimo.
Goodness sakes, guys. How many times should we tell you this? You are
Tell
proposing
us,
your
we just need to
explanation
one time
what you're observing.
Makes sense.
And
Just tell us one
therefore,
time that makes sense. That's it. That's all we're asking for.
therefore, you would test your hypothesis. And
Oh,
like
we
I
asked
say,
you for the definition of hypothesis.
goodness
How
sakes,
are you
I
gonna
just
test?
told you it's a supposition or a
Supposition for what?
preposed explanation made on a basis of limited evidence. So you've just seen something, need an explanation for this, further investigation, your answers.
It just sounds to me like a question, not a hypothesis. That's like, a kid saying, "Hey, mom, why did this happen?" It's not a hypothesis, is it? The kid asks you, "Mom, why does water fall down?" That's not a fucking hypothesis. It's a question. The kid saw the water fall down and he presented a question. Why did the water fall down? Not a hypothesis. Try again, Kimo. Can you please define hypothesis?
As I've outlined to you, okay, it's the process beginning with an educated guess or thought, okay, and when we have an observation, we are trying to propose an educated guess, not just a wild, outrageous fairies did it, a magic force that did it. We're looking for educated, reasonable, proposed hypothesis. Effective.
Yeah, again, Kimo, you're talking absolute bollocks, my brother.
Well, look, even though words hypothesis theory are often used ominously, a scientific hypothesis is not the same as a scientific theory.
Okay, in layman's terms, let's go back to the example of why water falls down when you turn on the faucet, the sink. Tell me an hypothesis of why that of just show me how that scenario can be hypothesized.
Well, that depends on the way the tap is facing, right?
Huh?
Facing up, the water will go up, depending on the power of the pump, or even like a fountain.
Right, so if that's what you think, present that in a hypothesis.
Like, let's imagine if we had the highest fountain in the world that could shoot all the way up into what you call space.
Is this your hypothesis?
The
Is
water
your
would
hypothesis
freeze
start with less imagine?
and wouldn't return
Start
back to
a
the
hypothesis
earth,
with less imagine.
right?
First of all, Kimo, you cannot start a hypothesis with less imagine.
No, I know, but that's how you guys start your hypothesis.
No, they don't. Nobody ever starts a hypothesis with less imagine.
It's
You
like
have
if
natural
this,
springs, fountains, man, that shoot out of the ground. You know this.
yeah, chemo, like start if this, then that. Is kind of like how you word the hypothesis.
Exactly. That's how we
I like that.
how we do.
Well,
science.
not necessarily, but
Say, Kimo, look in the chat. You'll be able to get a little help there.
What you got? What you
I
got
noticed
there?
we've gotten really far away from the atmosphere discussion at this point.
We have because you guys
Understand.
can't provide the container
It's being
or
added.
the gravitational force to hold the atmosphere down. So what we're going to discuss? That you can't provide the relevant information or demonstration. Where's the container? Where's the gravity? Where
all
is
right.
it?
Well, Kimo, why don't you do this? Why don't you present gravity and container bullshit in a structured hypothesis? somebody can actually test?
Well, we don't observe a container, so we can't test that. We don't observe gravity, so we can't test that. So none of this
Oh, I
is
didn't ask
science.
you to define shit. Tell me what you can or cannot define. I said present your question in a hypothesis that can then be tested.
Okay, if the Earth is a globe, then there
Here,
should be a gravitational force.
I got one chemo.
Okay.
This is the one I use for the mountain. So if gravity is the cause of gas pressure gradient, then gas pressure gradient should be observable from the center of this cause, the center of the Earth. So if you look at mountains, they have different gas pressure gradients because they're height off sea level, not because they're height from the center of mass. If mass attracts mass. I know that sounds like a shit show, but I just kind of shot from the hip.
Um,
No, I mean, like, well, that's for the globers. Any globers want to answer that?
Yeah. So basically, what I'm getting here is that if
I'm
If
not
there's a-
sure why you'd expect to see a gas pressure gradient from the center of the Earth.
when
Is
there's
that what
like
you're
no
implying?
gas there.
yeah, that's the pull or the force, the downward acceleration goes all the way to the center of the Earth. And the further away you get from the center,
Which center? Hang on. Which
exact-
Earth are you talking about? A flat Earth?
the
You're
globe
talking about a flat Earth or a spherical Earth?
yeah, a globe Earth with mass attracts mass.
Righto. So when you say the center of the Earth, what does that mean?
Right.
That means the middle of the ball,
The core.
the core. Sure, yeah.
Right. So there's no gas in the Earth. That
No, but there's
we can see
it
that.
moves. It moves that direction though.
It
Yeah, it's
moves
being pulled
toward the
towards the
center of
center.
the Earth.
Well,
Yeah.
yeah. And similarly, if you go in places where the pressure is
What's-
where the elevation is below sea level, then you get higher pressures.
What stops the gas from getting to the center of the core of the Earth?
Yeah, that would be the density of the Earth.
Okay. All right, carry on.
All right, thank you.
So if you continue, please, Creed. I'm trying to follow
Well,
you.
in those caves.
Oh, I thought you meant the other.
Well, why is it
people.
harder to breathe then in those caves underground? If there's so much air being pulled towards the center. Aha, think about that one, Glober.
I'm not sure. There could
It's because your lungs aren't used to that amount of pressure on them.
What, it's
Like,
too much air?
if some big fat dude sat on your fucking chest, are you gonna be able to breathe easily?
You're saying it's too much air?
Oh, there's too much force pushing down your lungs. Like, like if some dude sat on your fucking chest right now, you can be able to breathe as easily as you will without someone sitting on your chest.
You're saying the deeper you go under the earth, the harder it is to breathe.
Yeah.
The harder it is, the more you need to. Your diaphragm needs to work harder to push the air in and out.
Going really deep into water.
Not
Yeah,
underwater,
it's-
in a cave underground.
The
Diaphragm needs to work
Same.
harder.
Same.
Yeah, it's kind of the same, but
It's
it's
very
more,
similar to someone sitting on your chest.
There's more pressure. It's more constricting.
it's more heat down there too, though. That's the issue.
Yeah, I mean,
Not
we can
necessarily.
hypothesize perhaps why it's uncomfortable.
Well, I know a friend of mine who did some stuff with mining, and a couple years back, actually, well, decades back. So then he would have to drive if the drill broke. He would basically with a truck operator, and would drive the machines to repair the drill, the truck and stuff. And he said as you got lower and lower, it got so hot that you basically were like moving in slow motion. They did to keep track that you got like 30 minutes to do this task. Otherwise, you'll be completely dehydrated and you won't be able to breathe, and we'll have to send someone down there to rescue you.
Dang.
So it was dangerous work, yeah. And so that worked out that not so much that it increased pressure. It wasn't like scuba diving. Was they stayed down there too long, they would get the bends. They would get on gas, too much nitrogen. What was happening was it was so hot that it was like a humidity level, like a barometric pressure going on.
That makes sense. High
Yeah,
humidity
imagine it
and
like
high
you can
heat
do a mine.
tend not to
I
be
don't
very
mean like a
comfortable.
mine though. I just mean like a big open cave, like the ground cave.
Yeah.
I mean, I'd
Chemo's
imagine it's a
example,
similar thing.
if you just dig a hole, right, and just dig a hole straight down, does it add more pressure? And it doesn't. Like
Yeah,
sea
so
level pressure.
you guys should
is-
take a balloon under those caves and show how it gets smaller. No, will it get smaller? Yeah, it will get smaller and smaller. That's never been shown. Busted.
Actually, that's kind of curious. I'd like to see.
You say when you take it up a mountain, it gets bigger and bigger. So that means if you go into a cave, it should get smaller and smaller.
That's a great experiment you should go do.
Busted. So you've never ever shown this. That when you go below sea level, balloon gets smaller and smaller.
Yeah, if you want it done, chemo, go do it. Sounds like a lot of fun.
Not my claim, dude. You've been busted. You should have been under the underground.
If nobody's done, how can it be busted? You should go bust this.
Yeah, if you haven't done it, then what do you mean busted?
No, you should be showing this. It's not my claim.
Yo, you need to.
Why is it our job to do all your experiments for you, chemo?
Not my experiment. It's your claim.
You came up with the experiment. You're the one who just said.
Here's the thing, chemo. If we did that, what you would say is that's because of temperature.
No, let's have a look. Let's see if the balloon gets smaller and smaller.
You're saying if somebody did that, and I can probably find you a cliff of a balloon being taken down, someone dives.
That
right?
proves there's no atmospheric pressure. If you can't show the balloon gets smaller and smaller under sea level.
But it will get smaller.
You're saying that absence of evidence is evidence of absence, which is a fallacy.
No, I'm saying that you show balloons going up a mountain, but you never show them go below sea
your sentence
level.
was of the form, if you can't show X, then that proves that X is not happening. That's
I'm just
a fallacy.
saying there's a reason why you don't show it under sea level, because you know, well, not you specifically, but the people know that
Well, no, you're assuming that, chemo. It could also just be that no one cares enough to do this. It could also just be that it exists, but no one here has the video of it. It could be that this is a common experiment. It's just that no one's done it. There are plenty of reasons. You're assuming only one of them and trying to claim that that's the reason.
Okay, time will tell.
Yeah, thank you. That's a more honest statement from you.
But a real true flat earther who wants to know everything and to find the truth would go find out.
No, I've just busted you out because you would have done this ages ago.
But then you have to do it now because you have to have
I don't think I find it very appealing for my schedule to take time from studies and arguably more important things to go and into a cave to measure the size of a balloon to satisfy some guy on the internet.
Well, here I feel like I have done this because a lot of the pressure readings we take is at zero sea level. And basically the sea level is like 30, something like that, right? Like 30 barometric pressure, 30 something, like 30.8.
Yeah, 30. Shoot, what is it? What are the units of like barometric pressure in aviation?
Okay, hold on. I'm not sure. It's something like it's got some weird letters that doesn't make sense. It's not.
Yeah, it's probably like inches of mercury or something.
Yeah, like or millimeters or whatever, like mmgs or something like that.
Oh yeah.
It's everything so millibars, hectopascals.
There we go.
Okay. And so 2997 is inches of mercury, I think.
And correct, yeah, not only this, if you went underground under a cave, you would be lighter also.
No.
Yes, you should be lighter.
Why?
Yeah, well, eventually you're thinking if you hit all the way to the core, you'd be weightless, apparently, right?
Dead.
But hypothetically, right? If you got to the core, would you become weightless?
I'm
if
saying that you should become lighter because you'd be in more dense atmosphere, right?
You would. Oh, I see your reasoning now. Okay, interesting.
See how we begged the question for you and allow you to dream of this spinning globe, whereas most people will just shut this down and say, right, unless there's evidence, we're not going to dream of these.
Well, no, none of this has been begging the question. Those have been hypotheses that you could, in theory, if you wanted to, chemo, test for yourself. This isn't begging the question.
Yeah, we're already.
It'd be begging the question if you went ahead and claimed that this proved anything without having done the experiment,
No,
which is
about
what
the
you tried to do a
globe.
few minutes ago, and I
We're
stopped
begging
you.
the question about the globe.
You are heavier on the surface than you are higher up. So
Do you know the difference
really
between
get-
begging the question and assuming something?
Look, so you've got 2 experiments here, or 1 at least, with
Yeah,
the balloon.
3.
Take it underground, show that
Yep.
it gets smaller,
Yep, it
prove
will.
the atmospheric pressure.
Okay.
There is
Yeah.
that,
And
route in
until
there.
we see that experiment and the results thereof, best we can do is guess.
We can't
Or at least
prove
make
that
very
the atmosphere
educated
has any
guesses.
pressure. Yeah, we can't prove it.
Yes, they already did it, and the theory is that the rocks that are in the helium, when it was formed by the radioactivity decay, are slowly heated by the Earth's core, letting the gas slowly out, and then it will get to it will eventually go down.
Yeah, that's based
Okay.
on,
I wanna
the
hear it.
assumption there, Fun.
Hey, I googled it. You guys check this out. This is actually interesting. So they do inches of mercury.
Chemo.
No, I don't mean
Oh,
this. Not
Wait,
underwater,
let Crit
Branch.
finish. Let Crit finish real quick.
Chemo, take a look at the video I
No,
just
I
posted.
don't. I've
It's
seen this before.
exactly what we just
I've seen this before. I'm not talking about underwater.
the same shit.
No, it isn't. You've got to show underground in a
Wait,
cave.
why is water an okay experimental device when it's for your basketball experiment, but not for when it's freediving with balloons?
Because
Why
you're
are you so
trying to
picky?
prove atmospheric pressure, not water pressure.
Well, yeah, and earlier when we were talking about objects falling in the atmosphere, you talked about water. You were deviating in the same way
Oh
this person is
my gosh.
supposedly doing now. You're holding a standard of evidence for other people that you don't even hold to yourself.
Look, you're trying to show
Well, Spurs,
water.
why is it, Spurs, why is an egg in a glass of water, then pouring salt into it, okay, but not what Branch has posted?
That's what we see in nature. Eggs floating or sinking depending on the medium that they're in. Salt
This is the
water.
same.
Where
Is
have you
this not
seen
the
that
same?
in nature?
Oh, so
Is
we
this
live
not
in
the
water.
same?
Okay, fine. We live in water was. I agree. Remove the water.
Chickens
remove
don't
the
lay
pressure.
chickens don't lay eggs in water.
Yeah.
No. Chickens lay, or not chickens, but eggs are laid in nests, and nests are usually over lakes, and eggs can fall into lakes or
Chicken
into
eggs.
waters.
But
You need to watch. You need to watch
No.
more David Attenborough. Was
Okay, what was the observed phenomenon for your basketball experiment? Where do I see basketballs
there
in
was
nature?
no observed phenomenon. You said if I drop something, it will go to the center of the earth, and I said no. If you change the object, change the medium, the object will not go towards the center.
Yeah.
Oh, no one said that though.
That's what I'm teaching you guys. It's nothing to do with the force.
No
it's all
one said
down
that
to
the
the medium.
object will go to the
Except
center of the
chemo.
earth.
When we talk about how the atmosphere thins out into a near vacuum,
Yeah.
it's not thinning out into a pool of water. So why are you using water to describe the atmosphere's behavior?
And that's what we're saying. Branch is proposing a video showing water, and it's like we're talking about atmosphere.
All right. The fact that you're getting onto Branch about this water experiment is the same reason I'm now turning this on to you about you using water when we were talking about
Oh,
the
that was a
atmosphere
different thing.
earlier.
Yeah, that was a different thing.
Chemo,
Well,
I'm
yeah, of
holding
course
an
it's
apple.
different because it was you doing it and you hold
No,
yourself to a different
emerald.
standard. But that
Chemo.
aside,
Emerald.
I
We're
saw an
looking-
apple fall. I saw an apple fall. What's the cause?
Oh my gosh. Right, apple falling, emerald. You said drop something, apple falling. So you said it was a force that made it fall. Okay. So that same force, you should be able to make it go up. But you can't. With our hypothesis.
who says that same force should make it go up? Who on earth said that a force that pulls things down should make things go up?
Well, are you not in control of this force or what?
No, of course not.
You're not in
No.
control of this force.
This is why I said that in absence of external forces like buoyancy, so if we did this all in a vacuum, any object you throw up is going to eventually accelerate back down.
Yeah, but if
It's
you're
the
not in
same with
control of
it's the same with baseballs, it's with basketballs in the air, and it's the same
if
with
you're not
gas
in control
particles.
of the force, Emerald, what are we talking about?
Well, yeah. You asked the question. What keeps the atmosphere contained?
Yes.
And yeah, and I said,
I
well,
stand
there's a
alone
simple
on
observation.
this point until everyone wakes up and tries to show.
I mean,
force
we
or
don't even
control.
have to like this. This is so simple. We don't even have to use science to prove it. There's a simple observation that objects in the absence of external forces accelerate toward the Earth.
Look, this is where we have the problem. You keep on including things that you haven't tested for. Can't get away with it these days. Gotta
We
show
can
that-
do this with gas on Earth. If you sublimate CO2, that is to say, if you take dry ice and let the smoke come off of it, it falls.
Yeah.
So even gas falls toward the Earth.
Yeah, because it's,
So-
the temperature, it's density, isn't it?
So the atmosphere, which is more dense than a vacuum,
What would happen if you did that
will
in the
stay
water?
on the Earth.
What would happen if you did it underwater?
Depends on the gas.
would go up.
Exactly. You change the medium, you get a different effect. Change the effect, you change the medium.
Yeah, and guess what? You're talking about this supposed, you're talking
water.
about the atmosphere next to a vacuum, right? So the place to test the equivalent phenomena is in a vacuum. And guess what? No matter what we throw up in a vacuum, it always comes back down.
Yeah, why wouldn't it?
So a balloon in water would be fine.
There you
then.
go. We're done.
Different
Yeah,
medium?
there you go.
Well, who's done?
That's
Not we, you are done.
Well, there you go, Chemo. You're done. If you
You're
agree with
done.
that, then you agree that the atmosphere should not just fly off into the vacuum forever, because it should fall back toward the Earth.
Yes, but that vacuum is in a container.
Says who? I thought you didn't agree with the container.
Your experiment.
No, not ours. Yours.
You just said I had a
I
container.
can throw
a vacuum.
I can throw my baseball up, and it doesn't have to interact with that container whatsoever.
Yes, but you're in a container.
So
So that's the point. You can't have any of these things without the container.
well, yeah. If we didn't have a
Yes.
container around our vacuum chamber, the atmosphere would flood in. Ironically, the atmosphere would fall down to fill in the vacuum.
Say that again.
If we didn't have walls to our vacuum chamber,
Yes.
the atmosphere would fall and fill in the vacuum.
Exactly. Now you're getting it.
Yeah.
Okay,
we did.
well, let's approach it in a slightly different way, right? That video I posted, right, where the further you go down, the balloon changes size. How would you explain that on a flat Earth?
Water pressure.
If there's no gravity and everything's buoyancy and density,
It's all
Derivative.
so simple.
there's no,
But you'd
there's no
rather
change
make
in
it
medium.
hard.
Chemo, you do realize you just agreed to the death knell of your argument, right? Which is that the atmosphere would fall to fill in the vacuum. But in order to fill in the vacuum above it, it would have to go up forever. And that's not what we observe.
The gas is moving in all directions, and gas high pressure next to low pressure is a law of thermodynamics.
Not-
that
High pressure
says-
next to low pressure high pressure next to low pressure happens literally everywhere. The
Yes,
pressure
but-
at my feet is not the same as the pressure at my head. The pressure ahead above my head is not the same as the
That's
pressure
what
at my
we're trying
head.
to test. If you take your balloon down and it starts to get smaller, you're correct. That's the point.
Okay, well, Jem's here now, so I'm going to switch back to being a flat earther because I like to piss him. It's funny to piss Jem off, and he gets more pissed off if I'm a flat earther. So I'm going to switch back
Listen
to
up.
being a flat earther.
Listen up. Emerald, you made a very good point there. You just said it's higher at my feet than at my head. Now, we can only believe that if we have the balloon getting smaller and smaller when you go down below sea level.
That's false. We could also
Why?
just use barometers and avoid
No,
all
no,
the
no,
jibber
no.
jabber.
Not a barometer, because a barometer includes density. And it
What?
requires gravity, which we're trying to test in the first place.
You
So-
do realize that a balloon operates in the exact same way. The harder the gas pushes on the balloon,
That's
the more it
relative
compresses.
density. Yeah. No, that's all relative density.
Yeah,
balloon.
pressure.
The helium is lighter than the medium that it's in. That's what I tried to tell you, right?
Not when it's underwater.
Okay. And in a
Okay.
mercury barometer with a vacuum in the top, that vacuum is less dense than the air.
That's in a
You
container.
do realize that all the balloon is a makeshift simplified barometer, right? They're not fundamentally different at all.
No, because the mercury is heavier. So when you go higher, the tube it goes down, right?
The mercury is there. The mercury is the barrier between the vacuum
Yeah, but in
and
the
the
tube,
atmosphere.
in the tube, which way does the mercury
In
go?
the
Up
same
or
way
down?
that the latex is the barrier between the
You're not
helium and the
answering
atmosphere.
honestly. Which way does the mercury go? If you go higher in the tube, which way does the mercury go? Up or down?
It goes down.
There you go. So it's trying to find equilibrium. That's your density.
Yes.
Yes.
In the same way, it's the exact same with a balloon. That latex is denser than the air, But the only reason the latex is there is to separate the
It doesn't
helium
do
from the
latex,
atmosphere.
It's the helium.
Emerald. Okay, I'm a fluffer now, right? So, are you trying to say, Emerald, right? That if I'm in an underwater cave that's got a pocket of air, I've got a barometer in it, then I move sideways and put it inside water, staying at the same exact height in relative to the Earth center. Don't tell me that barometer reading won't even change a little bit, moving from a medium of water to a medium of air.
If you got it just at the surface, nope, don't change.
I'm talking about an underwater pocket of air, got a barometer in it.
Okay.
You take it and you put it the same height.
Yep, same reading.
Distance.
If
Barometer
you
reading
stuck
will.
it exactly at the water's surface level. Yeah, same
We're
reading.
not talking about surface level.
Hey, look,
okay.
guys.
Let me define this.
This is the
Let's
thing, you see.
imagine that we have an underwater cave which is 100 feet deep.
Okay.
Two identical barometers. One is placed 100 feet deep in that pocket of air in that cave. Another barometer, identical barometer, is placed 100 feet deep in water. Will they have the same exact reading?
They're all learning that there is no pressure. You're going to get this.
You're saying you don't even have an answer, do you?
Below sea level.
You don't even have to answer that question.
Hold on, cowboy.
Talking about
Right
flat
on.
Earth. They don't even know how to answer a simple question like that.
Without having thought
Mic
about it
check,
that
can you
long,
hear
I
me?
think, yeah,
What
you're
up?
good.
It's Babs in the house. We can hear you.
It's Babs in the house. I
Babs.
just want to
So-
add one thing before I go to bed. I think it's important to add this point. Now, we say that it's relative density that causes things to fall down, but I recently found a problem with that. If you consider the gases in the atmosphere, let's talk about the troposphere, right? The gases comprising the troposphere are nitrogen, oxygen, argon, carbon dioxide, and some water vapor. And what we notice is that in the troposphere, all of these gases are evenly mixed. They're not stratified, meaning that they're not arranged according to their densities. There's no hierarchy. And if it really was relative density that was causing things to fall downwards, you would see that stratification in the atmosphere. You'd see the more dense gases closer to sea level, followed by the less dense gases the higher up you go. But you don't see that.
Exactly.
But now
Good
here's
observation.
here's where I'm going with this though. It's definitely not relative density that's causing it. That is part of it, but I think that there is a force that's making it happen. That doesn't mean that I'm a glober. I just have a difference in opinion. And another example of that is like if you consider the density tower, you notice that all the liquids in the density tower are arranged according to their densities. They're not evenly mixed like the atmosphere. Carry on.
Could
Yep.
be something.
I appreciate your honesty. It's a good observation,
I
dude.
think that we need
Keep
proper
it up.
hypotheses
And that's the
to actually
beauty.
find these phenomenons that we see.
That's the beauty of the method that we follow. You see? Now, anyone,
Exactly.
no offense,
You
Babs,
keep
you know,
on those.
anyone, branch, anyone can say anything. They can.
Wait
come
a
up-
minute.
And I hope Bio's listening to this, because anyone can say any hypothesis about what they predict is a cause. But that's not down to us. That's down to the individual to show that that cause is actually causing that effect. So
Exactly.
if you're saying, Babs, then you know there is a
You guys are talking
force
about
of some kind. You
I
know,
would need to demonstrate that using the scientific method, and I can't do that. And granted, you guys can do that, so you do have a method of demonstrating cause and effect. I can't do that though.
that's where we
Yeah.
kind of lead the charge, because we're not providing poetry. We're not saying could be. I mean, again, a lot of flat earthers are doing this. You know, whether it's electrostatic, whether it's another force, whether it's a pulling force, a bias here, a bias there. Again, you can say anything you like, but the beauty of this method is unless you can manipulate your independent variable, you're just making things up. You're stuck in the hypothesis realm. You see?
I think
All right, Chemo. I'll give you that, Chemo. Let's say that it's not a force that's causing the phenomenon that we're observing.
fact that no glober can answer my
Wait,
question.
hold on.
I'm not even
Hang on. What if
disagreeing.
it's not a force? What is it that's causing there to be more particles of gas at sea level than there is at higher altitudes? What's causing that to happen?
Well, again, that's a wild claim. You're going to have to provide
That was
evidence
question,
that
not
there
a
is
claim.
more gases down here than there is up there.
Why?
It's not relative.
If you take barometric pressure readings at sea level, you notice
Mhm.
that there's higher pressure than there is at higher altitudes.
That would be air density. What we're looking for, Babs, as we're told, if you take a balloon higher, that balloon should get bigger and bigger and bigger, expand. So the reverse should happen if you take your
Wait,
balloon...
do you think barometers measure I'm sorry.
If you take your balloon
do you think that barometers
below...
measure density
Emerald.
and not pressure?
Emerald. I'm in the middle. If you take your
What?
balloon below sea level,
Eh.
Babs, we should, like, into a cave and lower, we should see the balloon get smaller and smaller. There's no evidence for this whatsoever.
Well,
That's
it does happen at higher altitudes. The balloons do expand and get bigger because there's less pressure acting on them.
I would
But
put
if
that
we
down
were
to...
to take it
And
to
it's
lower,
the exact same with other
my
barometers.
hypothesis would be a temperature change.
Emerald,
Now,
what you just said is actually the key. the
Branch,
question-
come on. We're going to lose
Can I
thought.
just quickly say to Emerald one thing, really quick? Emerald, what you just said is actually the key to the question I just told you, right? Asked you that it doesn't measure density, and that's why if you took it from that cave, or if you had it in water, it would actually be the same measurement.
Yeah, I think it'd be the same too after thinking about it for a bit. And thank you for helping me correct Chemo that barometers do not measure density.
right? Wouldn't the
They measure
pressure be
pressure.
higher, like at the bottom of the ocean, though?
No.
I think
Not
it would be.
underwater.
Then
not
where?
water. We're talking under...
It'd be greater than sea level because at the bottom of the ocean you have the entire mass of water that's above you.
Oh yeah.
So that's going to create larger pressure.
It's
Yeah,
not the water. It's not the water that's doing it, is it? It's not just the water. Otherwise,
So all the water.
the whole fucking cave thing that I presented wouldn't make any type of sense. Why would the biometric pressure be the same?
The pressure at 100 feet depth and the pressure at 100 feet depth, which is also the surface of your cave, would be the same.
But if you look at the post, there was two explorers that took a balloon mission, and it tells about them going into a cave and going to a lake. But the lake had a certain type of
So, Babs, I mean, back to your point. I mean, again, this idea that there is more pressure, there was a bias down here, and there is just no evidence for that. You're going to have to show that temperature is not the cause of what we're experiencing, and pressure is the cause. And then I would have to ask you again, where does the pressure come from to create this gradient? There are so many problems when we invoke pressure that
Emerald, actually, Emerald, there would be a difference. Emerald.
Well, the pressure comes from the weight of
Hold on a
the
second.
gas.
I thought about it a little bit more.
Right, Branch, you're going to have to
Would
take
be a little bit of
5 to 10 minutes.
It would be a
because
tiny amount of difference.
Branch.
It would be small, but you would have a balloon would get a little bit smaller in the water just because there's more shit above it. There's more mass above it.
So stressful, Branch.
Yeah, the pressure is caused by the weight of the gases in the atmosphere.
The weight,
That's what the cause is.
Everything above you, right? Whatever's pushing down on your head.
Yeah, it's a weight pushing down on you from above you.
So pushing.
So
require-
in the cave, there's going to be that little bit of difference where you got your head to the ceiling of the cave where there's air and not water. It's going to cause a difference in your pressure.
Yeah, I don't know how to answer that.
So it'll be super small unless you was in an enormous.
I think the difference would be negligibly small.
I'm just saying, there would be, like, if you're going to get really scientific about it, it would be a very slight difference.
It would depend on the depth that we're talking about. If it's not a significant depth, then you wouldn't notice any significant depth.
I mean, if you're using a balloon, you're going to have error anyway because your balloon takes up more
Yeah.
space. Like you want a localized pressure reading.
Yeah, I mean,
Because if you dip, say, your balloon halfway into water, halfway on the surface, the bottom half of your balloon's going to be compressed more than the top. And then it's like hard to gauge what the pressure is based on that.
yeah, I mean, it'll be super negligible, right? That's why, like, people don't have to go in decompression. Like, if they dive super deep and they get into a cave, don't have to go to decompression before they get in the cave. They're totally fine.
Yeah, the pressure of that air is higher than the pressure of the surface.
Okay, so Babs, the idea of weight suggests there's gravity. Yes, because there was a push, there was a pull, however you want to describe it, there was a pressure, and obviously we can't have pressure without that force. So where does that pressure come from? Yeah.
Was I roboting? Can you hear me?
I hear you now.
You're good now.
Where would that pressure come?
The pressure comes from the weight, and yeah, that does in fact require the force of gravity.
You know, gravity's not a force, so where does that leave you, my friend?
Why is it not a force?
Because there's no evidence to suggest that mass attracts mass. There is no evidence of a downward bias. There is zero evidence of a pulling mechanism in nature. Yes, so there are various reasons for that. But
Wait,
again,
I'm
I'm
gonna press you on
open-minded.
this. What do you mean there's no evidence of a downward bias when literally everything dropped in, say, a vacuum
open-minded.
falls
Now
down?
remember, if we have a cause to this effect, we have to manipulate that independent variable.
Well, no, you've thrown like 3 or so claims out, and I'm not going to let you slide without having them challenged. You say there's no evidence of a downward bias. So why do objects, when say they're denser than air, fall downward and not in any other direction? There's very clearly a bias by nature.
Temperature makes these gases more dense, and this gives you that direct. But again, there is no direction when it comes to relative density.
You said earlier that if you're going to claim the cause, you need to have evidence to back it up. So did you do an experiment that proves temperature causes any of this? If not, then you're just spouting bullshit.
Yeah, I mean, there are many tests. You can see.
Have you done any of them?
Yeah,
have you verified this?
Fall?
Well, we have the egg test. You're familiar with the egg test, yeah?
Yep.
I think I'm back now. Chemo, there's also another issue with the relative density thing, because even in your paradigm of relative density, if space is a vacuum, that means that the gases would still fall through the vacuum.
Right, that's what I was trying to tell you earlier, Chemo, is that the atmosphere is more dense than a vacuum, so I could just invoke relative density, and by virtue of that alone.
How I understand it is like, so the stars are in a medium, they're light enough to be in that medium, okay, and that medium is above this medium, yes, and it's like a density tower, Babs. So you have the water, and then you have this medium, and then they have another medium above that. It's not a privation of any kind. This is a place where the stars and the planets, or if you want to call them planets, they actually reside in this medium.
Okay. Who's to say that the stars?
How come the gases in the troposphere are not stratified? If that was the case, if it was relative density that was causing this effect, why are the gases not separated according to their densities? They're all evenly mixed within the troposphere.
It's relative. It would be relative. So they're all constantly moving, constantly trying to sort themselves out. But you have like heat, which is constantly giving you fluctuations, yes? And constantly things are trying to settle in their order. Dynamic system and all that, yeah. But
I
again,
mean, I can't argue that because temperature does affect kinetic energy. But still, though, I mean, wouldn't you expect the gases to be arranged according to their densities? Like, why would it be evenly mixed, even if they are moving around randomly?
Well, I mean, again, you say the gases. I mean, again, gas. There's a lot when you say this. Again, are we following what they tell us about what the gases are? Are we saying they're bouncing spherical objects? You know.
Oh yeah, I don't have any practical demonstration of this. I'm just reading this off of the textbooks.
Right. But I mean, again, all I'm interested in, again, because what we're doing now, Babs, is we're theorizing, and we're this is poetry. We don't know any of this, and this is what we want to do. We obviously want to find out what's going on, but if any claims have to be tested. So for me, we've tested the relative density. If you're not satisfied, or anyone's not satisfied, and there is another cause, well, let's take a look. Take a look at it.
I'm not denying relative density is part of it, but it's not the main cause. It's just part and parcel of gravity. It's not separate.
Is that a feeling, Babs?
I'm kind of convinced with this whole atmosphere thing. You know, if someone could explain to me how that works with relative density, then maybe I would think differently.
Well, you know, like I say, I mean, what is the atmosphere? What is air? What is it gases as we're told? I mean, as I understand, gases that are pressurized would liquefy. As we see in a can, when you shake it, you hear like a liquid type of fluid at the bottom of the can. We don't see that here.
Bottom of the what?
Wouldn't that apply to a fixed volume? And we
Wait,
don't
at the
live in a
bottom of
fixed
a what?
volume.
Well, it would require pressure.
I mean, certainly if you pressurize gas enough, it will liquefy.
Well, I mean, when you shake the can, there's always like a bit at the bottom that you have to shake around, right?
But doesn't that require a fixed volume in order for that to work? And we don't live in a fixed volume.
Yeah, that's a
Right,
pressurized
like
can.
the ideal gas laws that everyone loves to quote are just that. They're idealized. They're approximations of gas behavior. And so when someone says, like, in an ideal gas, you've got, you know, pressure and volume, and then they ask, what's the volume? Well, we don't know, or we don't know if there is or isn't a volume to the atmosphere if we don't, you know, assert any specific model.
Right. And why does there have to be a container above the flat Earth? Why can it just not be? Well, why could it not be an open system? I don't see why you guys have a problem with that. It can still work, and it makes a lot more sense to me that it's an open system. And the pressure is only a result of the weight of the gases.
But again, you can only get this from a force or a container.
Right.
But
Kimo,
that's
can I just touch on
that,
something?
So, Space Pope, I appreciate your honesty that you're open to this when a lot of other people are really close.
Yeah, no
off to
problem. No problem.
Yeah.
But
Space,
Kimo,
did you say
you-
relative density before, just to clarify?
Wait, Emerald was talking.
I was talking about it.
It's fine. It's fine.
I was talking
But
about
you didn't
it.
even get your point
using
across. I
Kimo's
was actually
example.
waiting to see what you was about to say.
I'll restart it. It's okay. Let them continue.
Can you guys not hear me right now?
Yeah, you're good. Go ahead.
Oh no! When I was talking about relative density, I was just using Kimo's example.
Go ahead, Emerald.
I'm not denying that relative. What the
Don't do
hell
it
is
again,
wrong
or
with
I
you,
can fucking
Branch?
ban you, bitch.
Why do you keep talking over me, Branch? You need to stop
Branch,
doing
it's
that, man.
fine. I'll state my
No, it
point later.
wasn't. Sheeple, I want you to apologize to Emerald.
Well, I actually spoke in between, and I don't know if it was a delay or whatever.
Branch, it's okay.
And you're only taking it further away, and it would have been a quick thing, and I would have got away just by telling him that relative density. Shut up now, please. Relative density. Another name for it is specific gravity. So I just wonder why Kimo's using that, and why it needs to be explained when it's called specific gravity.
Yeah, because relative density is
He was
part
in the
and
middle of a
parcel of
statement.
gravity. So when you say relative density, you are
You gotta
invoking
see.
gravity.
You can't just wait for a.
Yeah, that's what I mean. And Kimo mentioned that, and you mentioned relative density, and it's just a specific gravity is another name for relative density. So I'm just wondering, he's denying gravity, but then using gravity. I just wanted to clarify that was the word you repeated, in case I missed anything, and that was all I wanted to say. So it would have taken a lot less time if Branch, you would shut your mouth. Sorry, Emerald. Away with your point.
You're good. But so I appreciate Space Pope's openness to all kinds of hypotheses and actually critically thinking about what could be happening. And if it makes more sense that it's an open system, then that's a good thing to explore. But from what I've seen from Kimo, you, and folks like QE, is that because they read from someone on the internet that the scientific method requires this very stringent set of guidelines on what is or isn't science, and that knowledge is restricted to just this one subset of plausible science experiments, that you've locked yourself into these claims like gas pressure requires a container, which are asserted from definitions you've read on the internet, but aren't actually backed up by demonstrations. Sure, you can on the surface of Earth build a container and then say, well, look, my gas pressure has a container. But unless and until you know whether the atmosphere has one, your claim is basically unfalsifiable.
I'm not claiming there's a container. You are claiming there's a container or a force, neither of which you've managed to prove. Sorry, Jem, go ahead.
I'm referring to your claim that gas pressure requires a container. Because let's suppose the atmosphere has a container. Then The only thing we'd know is that all the gas pressure we see on Earth is contained. That doesn't mean that all gas pressure requires one. Or say the Earth doesn't have a container. Then there's an obvious counterexample to your claim. So it's not known
Yeah,
to be
but-
provably true in either
But
case.
if there was
Jem
a
wants to
container,
say
the
something.
pressure would be uniform everywhere. It wouldn't be
Mike's
there
low,
wouldn't
by
be
the
a
way.
pressure gradient. It wouldn't be pressure. It would all be uniform if we were under a container.
Fuck.
Don't you think so?
In the absence of like some other kind of force, yeah. Like if
Exactly, and that's what I'm saying. If there's no other
Chemo,
force,
Chemo, one thing I'm
pressure
gonna
would
say,
be
Chemo, is
applied.
look, you interrupted a very decent conversation. Me and what have you.
For a conversation.
About technology and shit that actually is going to affect all.
okay, that was because there was nothing else to talk about. If there are people here who wanted to talk about debate, then we can take that offline. Our other conversation.
Well, Jen wanted to say something on the sign. I don't know what he wanted to say.
I was just saying, well said to Emerald. I thought what he said about the way you're limiting yourselves with this scientific method.
Mike is low.
Oh,
I actually don't think it's a bad thing. I like the fact that we have differences of opinion within the flat Earth. Like if we all thought the same thing, then it would be cultish to some degree.
Yeah,
Well,
I feel like it strays a bit too close for comfort toward that in some other servers. But
Why can't we be proven wrong? We're not saying we should accept this, you should accept this. We're saying if there is another way, well, let's look at it. But you haven't provided.
that in my experience has not been the case. Every time I've discussed this, including this conversation, you have asserted to me that gas pressure, or like other flat earthers have asserted to me that gas pressure requires a container.
Pressure, yeah.
Yeah, which is interesting because, as has been pointed out, this relies upon the idea of gas laws. And you're talking here about what are also called hypothetical gases, right? These are models of gases. These are concepts that you guys object to fundamentally. Go and have a look. Just Google ideal gas, and you'll see they are hypothetical gases.
Yeah, but
So why are you drawing conclusions on hypothetical things?
I'm only arguing from the perspective that you guys say you have atmospheric pressure, gas pressure, whatever you want to call it.
Yeah.
So, in order to have that, you've got to have a force or a container.
I would disagree. The only thing we need is if we can observe that this gas has some reason to stay by the Earth. We don't have to even claim why it stays near the Earth. It could just be a natural law that all objects move toward the Earth. There could just be some natural inherent downward bias to the universe.
Nice poetry.
In fact, I think most flat earthers claim that ultimately.
No, but
that there's
listen
an
to what's
up and
being
down
said.
in nature. That's what gives
Chemo,
density
this isn't
its
just
vector,
poetry,
right?
Chemo.
No,
What I'm
but
getting
both
at is
yous
that
now
it
are
doesn't
doing
actually
both. What
matter
I'm
how you
talking
even
about. Hold
characterize
on,
this
you're
downward.
saying your method, you and Jem Emerald are both saying this method that I'm talking about now is, well, we should do like this and da-da-da. I'm asking you for your method, and you're saying, well, you're not even giving me a method. You're just criticizing.
Well, my
this
method would be to make some observations, and I would observe that I can see gas pressure without a container.
How? Where? Whoa, hold on, Emerald. Where? How?
The Sun, Jupiter, and the Earth.
How do you know it's a gas?
Because what
Well,
we
let's not even
see
get
has
into this.
well,
This is the point.
because we've tested these things, we can
No,
use spectroscopy.
no.
But beyond that, just by observing, for instance, Jupiter, I can see clouds of stuff moving around in a fluid fashion. This indicates that I'm looking at gas.
No, you have to guess. You're hypothesizing without.
We don't
can
have
call it
to
a
use
guess.
science.
I would
Like
say
if-
it's an
if the-
educated guess based on the observation.
Okay, you take an educated guess, then you've got to
If
test
I
it.
see something that looks like gas, I make the guess that it's gas.
But then you've
You
got to
can
test
call it a
it.
guess, but
That's it.
All right,
I mean, if we wanted to confirm that, we could
So
try and use
hold on, let's
spectroscopy.
fight. Let's establish.
it wasn't me, Branch. It wasn't me.
Who is a mutant branch?
The only thing we have that defines how gases work is the ideal gas laws. Why is it that these laws specifically state that the molecules that the gas makes up don't have any type of impact of gravity.
No, look, I need to get back to Gem and Emerald here
These
because
work by
my
negating
God.
gravity. Why is that?
Branch.
Hey, Chemo, about 2 months
This
ago,
is real
I made
talk,
a.
bro. Ideal gas
Look, he's
test
not letting
assume
anybody talk, Babs.
no
I don't
mass
know who keeps on
and they
muting him.
have no impact
He does.
on gravity.
They don't want me to talk. They
Yeah.
don't want the truth to come out.
Go on.
A few months ago, I made a video in my basement where I manufactured carbon monoxide and poured it onto a triple beam scale, and it recorded a 0.3 gram reading,
Yeah.
if I remember. I just posted the video, and you can look at it if you want to.
Oh, no.
That just proves that gases have weight. Because why would the scale register anything if gases didn't in fact
Where's
have
the
weight?
video?
I just posted it in the
24
chat.
minutes after the hour.
Oh, yeah, yeah.
It's actually a really great video. Thank you.
Take a look at it.
There are a
No
lot
worries.
of folks who claim that gas doesn't have any kind of weight.
Yeah, that's where
This is,
the arguments had to go, isn't it? But as you say, Emerald, most of them claim if you ask for where the vector comes from for density and buoyancy, a lot of them will end up saying, well, there's an up and down in nature or something of that,
Well, can I stop you there? Sorry, because I've just watched
something
it.
along those lines. So
Babs,
if that's the case, why do we need the container?
Babs, you know where the pressure comes from in this experiment of yours?
Yeah, it comes from the weight of the gases.
No. It comes
Where
from
What
does
do you
it
mean,
come
no?
It comes from the
How'd you
container.
disprove that, Chemo?
It comes from the container that you've poured it from. Okay? That's where the
Okay.
pressure has come from. It hits off the walls, it comes out, it pours out onto the scales. Now you have two walls. You have your scale and your glass jar to give you the pressure, obviously, that you need to measure, Babs. Now, try to do this without either container, like the other side, the other wall, and you won't get a pressure reading. See?
That was
Probably
ridiculous.
not, but the gas is no longer contained when it's on the scale.
Yeah, it's all connected. It's connected through the scales, streaming up through the gas to your.
Well, no,
clear
the
here,
behavior of
Chemo.
the behavior of the
Let's be clear here.
scale.
He didn't get a pressure reading. He got a weight reading, Chemo.
No,
Don't
no,
use
no,
words
no.
incorrectly.
Look,
And this is probably a bad example. Let me give you a better example. If I have a book,
this is a good example. The
This is a good
purpose of the
example. It
scale
shows you
is
that
to
you need a
measure when
container.
things
Weight,
push.
right.
Is to measure when things land on the scale. It doesn't matter
Right.
where they came from. There's no
But I think-
reason that the scale doesn't communicate with the bowl to somehow make that bowl the cause. Like if you want to assert that, Chemo, you're gonna have to show that. But don't just
well,
say
he could
no.
argue that the gas particles are bouncing off of the scale. That's why I wanted to use a different example that doesn't involve this. If you take a balloon with helium in it and we weigh that balloon and we add more helium to the balloon, it's going to be heavier after that. Why is it heavier if gases don't have weight?
because you can't weigh gas without a container, Babs. You need.
Yeah, but why is it heavier though?
Because you created more pressure,
No, because you've injected more matter into the balloon.
which creates more pressure on the
And then as
walls
you
of the
get
container.
But the scale is not reading the pressure; it's reading the weight of the balloon.
Yeah, but you can weigh gas in a container. No one's argued that.
So gases do have weight because if you're weighing something, isn't that reading its weight?
In the container, you can't weigh it without the container.
Yeah, you can. I just demonstrated that with my video.
But you had two walls, Babs. You had the scale and the back of the jar. There's your two walls.
Right.
Mm.
So how can we demonstrate this then? If we can't do it this way, then how are we going to be able to demonstrate it?
Was this gas contained?
What?
When it was
I
weighed?
don't know. I mean, again, it's not my claim, so it's kind of not my problem. But you'd have to show that the temperature is not any affected, and you'd have to show there are no walls. I mean, you showed two walls. You had your container, one end, and then
So in other
streaming
words,
down
what
the-
you're asking for is you'd like us to build an experiment that is so highly controlled that it isolates for every thinkable cause you can come up with, but it's also so uncontrolled that we don't have any kind of barriers to keep the atmosphere and environment in.
Well, no,
And
all you're
we're not
doing
the
is
ones
trying to demonstrate that there is pressure, not temperature. And
Well,
all we've
yeah, but
demonstrated
what your
so
standard
far,
of evidence here is you're telling them that they have to simultaneously control all these variables while also not having any kind of container that would keep the outside environment out. Like if you tore down the building, then who's to stop the wind from affecting the experiment?
Yeah,
Or
but
who's to
again,
stop
we
the
know-
sun from beating down?
I don't understand. We know you need the walls of the container to weigh the gas to get the pressure. That's where it comes from. That's where it originates
That's your
from.
claim. Don't say we know that. That's your claim.
Yeah, but we just had an experiment from Babs that just shows we've got 2 surface areas, and he got a reading.
Yeah, but he didn't manipulate the container. He
Oh
just
my
poured it,
gosh, he's got the
so-
scale surface and the container surface inside. There's your 2 walls.
Just because he's got it doesn't mean he manipulated it. You're forgetting your own method, Kimo.
Nothing to
You have to
manipulate. All he's
manipulate
doing
it.
is weighing the gas. So all it is just
Yeah,
like
he's
having a container, and then one side has got the scale on it, which what Babs had was scale. He didn't have 4 walls.
But he's not changing the container. He's not messing with the scale. He's
No.
not messing with the jar.
6 walls.
He's not manipulating the containers.
Nothing
So
to
you're saying the
manipulate
containers
here.
are the
All he's
cause.
doing
It's
is weighing
not.
the
This
gas.
experiment doesn't show that,
There's
Kimo.
nothing to manipulate.
There you go. So this is not a scientific experiment that proves that the containers cause
No,
it.
it's just,
Thank you.
It's just weighing something. He's trying to weigh. He's trying to see if he can weigh the atmosphere without a container.
Yeah.
And he didn't do
Do
that.
what
we
you've
really
gone ahead-
need?
what-
do we
what
really
you've
need
gone and done-
scientific? Do you really need scientific experiments to prove everything, though? I
No.
think there's some things that
I-
don't require science to be proven.
No, you don't need science for this. You're just making a measurement. You're trying to measure if the atmosphere or the air has
Yeah.
weight.
Yeah, so it's
Yeah,
just a
and there you go.
measurement. It's not an experiment.
No,
And this,
that's why I said there's no.
shows that it does. But yet here you are saying that somehow this is all actually caused by the containers. That's a cause and effect claim. You're trying to inject some kind of
Yeah,
scientific
but you can't
cause
have
and
gas
effect claim into
pressure
this simple
without the
measurement.
container, without the walls of the container.
Except that once the gas leaves the jar, it's no longer contained by the jar.
But it's got 2 walls. You've got the jar and you've got the surface of the scales.
I just said it leaves the jar.
But you've still
So it
got
doesn't have
2
two
surfaces to measure it with.
Nope,
That-
the
But
scale measures only things on its surface. The scale has nothing to do with the
Well,
jar.
then what?
Doesn't
Okay,
communicate
that's
with the
fine.
jar.
Okay, if that's the case, then pour the gas out and let it rest on the scales.
That's impossible.
Exactly. So if
That-
it's not the jar, then you won't need the jar to show that it's got weight. You'll just show that it's just the gas. You haven't shown that. You've just shown that you've got a surface and another surface, and in between those 2 surfaces are gas. Is gas.
But do you know why it's impossible, Chemo? Do you know why the gas doesn't just sit on top of the scale?
Of course I know why. It just goes in all directions.
No.
Well, not generally. No, it just diffuses into the available volume.
It's weightless. You
So
can't
that could
weigh
be in
it.
any direction.
You can't weigh it, Babs. The atmosphere cannot be weighed. It's weightless. And the only way you can weigh it is by putting it in a container.
So what does a barometer do then?
A barometer measures what's in the mercury one.
The mercury barometer.
Any barometer.
So
they all do
when
the
you
same
go
thing.
higher with it, does the mercury go higher or lower?
So, Chemo, if we put the container on the scales and tear the scales,
So if
the
it goes
scales reach
lower,
zero-
Babs, it's trying
Chemo,
to.
I was
equal-
talking. I
Go
was
on,
talking, Chemo.
Go on.
Chemo,
Go
I
on,
was
Paul.
talking. Chemo, no, you hold on.
I said
Fucking
go
hell.
on. Go
Keep
on.
right.
Paul, it's all good.
Alright.
Go ahead, Paul.
Yeah, thank you. Right, so if we put the container on the scales and then tear the scales so that they read 0, and then we add the gas, aren't we just measuring the gas, Chemo?
Paul, I don't know why you get so angry when I'm just,
Because you're a rude cunt, that's why.
Oh, for goodness sakes.
Answer the
Wait,
question.
what
though,
was his
Kimo.
question again? Could you ask the question again?
The question was, what if we put the container on the scales and then tear it so that the scales read 0, and then we put the gas in? Aren't we then just measuring the gas?
Yeah.
They're going to say that it's in a container still.
Yeah, you are measuring
has
gas,
to-
Paul. What's the problem?
It has to not be in a container for it to be valid.
But
They're
Paul,
not
what's the-
going to...
Paul, what's the problem? Okay, you tear the container, you put the gas in, you weigh the gas in the container. So what?
Yeah.
It's pretty
The
self-explanatory.
only thing
I
you've
thought.
changed, the only thing you've changed is what's in the container.
Okay, so what?
It shows that there's a weight. If there's anything registered after you zero it out,
No one's
the
denying that,
weight
though,
can be
are
the,
they?
the weight. Well, you
So
are.
gas has weight.
In a
Yeah,
container.
you're an
Oh
idiot.
my gosh! So we live in a container then, yes?
Why would the
How do you
container
give
give
up?
gas? Why
No,
would the
we've
container
already-
give
we've
the
already
gas?
You
zeroed
don't even
out
know
the
what you're
container.
saying here. if you're saying it requires a container
He's
to
lost.
measure it, then you're saying we live in a container.
Are you implying that the gases don't have a weight when they're not in the container, Chemo?
Exactly. The atmosphere has no weight. You cannot weigh it.
Emo,
That's
can you
why
weigh
you-
water without a container?
How come you can feel wind blowing on your face if the gases aren't made of matter or particles?
Oh, just
You
run
can-
your
you
hand through the
feel,
air fast enough, you can feel it.
Temperature, and you feel like you feel the
This is
temperature. Yeah.
ridiculous.
No, but you feel a physical thing pressing against your skin. How is that not matter?
Yeah, so you're feeling a press through the
Yeah,
wind pressing on
Yeah.
you. You're feeling the particles. There's a force behind that, yeah. Wind. So what?
There you go. You just derived your gas pressure.
What are you
Oh.
talking about? He's talking about when he feels something on his body. There's a cause.
You just said it right there. The gas particles hit it, and it makes a force. And you know what we call force
No, I
over
didn't
an
say
area?
that. I didn't say that. I said he feels something on his body. We know the wind is blowing. The wind is the cause of
And you
this
said
pressure.
quote. So there's and you said quote. There's a
What
force
is wrong
there.
with you? What is wrong with you?
Feet
We're
to the
talking
fire.
about cause and effect. The cause of this pressure was from the wind, not
in the
gravity,
chat,
not the container.
Yeah, and you know what the wind was by your own admission? Gas particles hitting something.
And what was the cause of
That's
that?
exactly-
What was the cause of the acceleration?
What acceleration?
Of the particles hitting him.
When they hit him, they collide with him. and
Yeah.
they
What
accelerate.
caused the particles to move, to come at him?
Doesn't matter.
Oh,
That's
it
not
doesn't
what causes the
matter.
pressure.
So was it gravity? Was it a container?
Doesn't matter.
Okay.
Well, here's the thing, Chemo. Here's the thing.
You've already been-
still
you've been
got the
cornered, dude.
same phenomena on a flat Earth concept. So where does it come from if not gravity? What is it?
Not just that, but those particles also have mass. Because if
Yeah.
they didn't, you wouldn't feel them when the wind was blowing on
But
you.
we know the cause. We know where the force comes from, Babs.
You're an idiot.
The things just fly at you with no cause. No, there has to be a reason why.
Okay,
and
well,
how
how does it work on a flat Earth?
How do
does
these
it work on a flat Earth?
particles? How do these particles get to
Space
you in the
Pope,
first
I think you're right
place?
here. I think hopefully you can realize why we get frustrated talking to certain people, because you're so far the most reasonable person.
Well, if you make wild, outrageous
talk to
claims, then you're going to have to back them up with science.
Well, no,
I'm
you've
also
actually
very
already done the
thankful.
admission for me. You've already described
And what
where
we've
gas
seen,
pressure comes
again,
from
with
for me.
Babs is a very good example of our position. That's how
He's
strong
moving
it
away
is.
from what he just did.
He had two walls,
You're moving
which
up-
is
you're
the
moving away from
absolute
the wind.
definition of gas pressure.
Yeah, but I also showed that with your position, Chemo, you don't require a container. Because if the vacuum of space is less dense than the gases are always going to be moving downward.
The vacuum of
They're
space.
not going to move in all directions.
What do you mean, a vacuum of space?
If there's a vacuum above us,
Mm-hmm.
then the atmosphere is going to be more dense than that vacuum, right?
In the
Tried to tell him this before.
I don't know what you're saying here. You're saying in the vacuum there's going to be density. What density?
Well, if things are arranged according to their densities and the atmosphere is more dense than an empty vacuum, then why would the gases move outward into space? Why would that happen?
Because there is lower, what you would call pressure, there next to the high pressure.
What do you call it?
Basically, Spurs, you don't need a container on flat Earth.
So, Babs, when can you show us?
Exactly, you don't
the
need a
atmosphere is
container for
denser
that
than
to
nothing.
happen.
I can't believe I'm
Yeah.
arguing with Babs. I don't want to argue with Babs. I'm not arguing with Babs
if you're gonna
about this.
if you're gonna object to gas staying near Earth because of a difference in pressure, then that's inconsistent because there's always a difference in pressure. There's a gradient basically everywhere. Yet somehow the gas doesn't just rush upward continuously, yet you apply that standard to say that the gas must rush into the vacuum. It's inconsistent. at the
And
very least.
why is there even a gradient to begin with?
Again,
You know, like,
gradient.
just like the point that I made earlier, the gradient is not based on the density of the gases. The gases are all uniform in the atmosphere. So why is there a gradient to begin with?
Yeah, but how do you know if the gases are thinner up there?
Because you can measure.
Because we can measure it, Chemo.
That means you believe in space, Babs.
No, I
You
don't.
just got to climb a mountain.
Well,
Climb a mountain,
Babs,
Timo. You'll realise
Babs,
it's harder to breathe.
hold on, sheeple. So, Babs, if it gets thinner and thinner and thinner and thinner and thinner and thinner, when does it stop? How does it work?
It What do you mean? Where does it stop? Why
You're
would it
saying
stop?
that it gets less. There's a gradient that tapers
Right.
off. So talk to me. Where does it stop?
It doesn't.
So forever throughout the universe, it just gets thinner and thinner and thinner, all the way to the moon, past the stars, past the sun, all these things.
Infinitesimally small. Yes.
Well, I personally don't believe in outer space, but I do believe that there's a lower pressure system above us.
And then what? Into space, into nothing.
Well, you could argue the same thing with the dome. What's outside of the dome?
Well, according to the biblical cosmology, we're surrounded by water, but that's another story. What we're talking about is the pressure here. You're saying it gets thinner and thinner, because this is based on your argument. So it's
Right.
hard not to kind of argue like this with you if you're going to just claim, well, we've got a gradient.
The logical thing to assume is that if it keeps getting thinner, then it eventually turns into a vacuum. And
Right.
if you're saying that there's water above the dome, first of all, a
No,
dome.
Babs, you got to be fair. That's Bible stuff. We're not. I said that's a different
That's
story.
Bible stuff, right?
Yeah, we're not
All right,
arguing.
even if there's no water above the dome, something that size structurally just wouldn't work. Think about it. How can a curved dome support itself? It would just
Why
collapse.
is it curved?
That amount of weight could not be supported with that kind of stuff.
Again, Babs,
Yeah,
see that,
a lot of weight.
Babs, this is not this. I'm not. You're looking for a way out now. Okay, I only brought that
No,
up.
he's asking for your opinion.
No,
by
that was the
asking your-
point.
He
I'm not.
is.
Yeah, but this is just my my
Well,
faith.
but you've attacked his point, so now you've got to explain how it doesn't work the way he just explained it.
No, because I'm saying if he's saying if his position is it gets thinner and thinner and thinner and thinner, then what? Does it go thinner into space? Then what? What goes
It's
next?
not just his position, Chemo. It's not just his position. It's a demonstrable fact.
What I said
We
that
can measure the pressure of the atmosphere decreasing as you go up. All he's doing is taking the logical conclusions of that, and you're basically saying, well, I mean, you're asking him then, what does he think happens? And he's already answered that. He says he believes there's some low pressure system above us.
Like
What
space.
other question do you want to ask?
Like space. I just want to clarify.
And
You're saying there's space.
no, I don't think like space. No, because I don't believe in space.
But Babs,
Okay.
you've got to level with me. Where does the atmosphere go to the moon? How high does it go?
I know that the Geo Corona goes as far as the moon. I could be wrong. I don't know. But
see?
just
Yeah, aspects.
How can
very,
can
very
we,
small.
if we're trying to do real practical stuff and like the borders say,
Climb a
well,
mountain.
it's just thinner. How they can't
It does,
validate
though,
that?
chemo.
They
It
can't
does,
validate
chemo.
that, can they?
but
I
what's,
have validated it.
what's wrong with that though, Chemo? What's wrong with there being a vacuum above us? Why is there a problem with that?
Because we cannot have high pressure next to low pressure without the force or a container.
But there is a force.
Well, that's what I'm saying.
There's
If
a
you're
force that's keeping the mass stuck to Earth.
again, I'm not going to argue with you. If you're saying there's a force, then obviously we know what we've got to do. We've got to manipulate that independent variable. Obviously.
Didn't Blue Marble Science do that with his Cavendish?
No, we're waiting for... Because remember, if we're dealing with variables, again, we shouldn't really accept Cavendish. But again, just to work with you guys, we will accept it and say that it is a scientific experiment where we can account for variables. Now, with Blue, we know the cause to his effect, which is atmosphere, and he would have to remove that draft, which would be done in the vacuum, which our good friend
Just
here,
making shit
BioJewel...
up now.
How do you know that?
so
Our good friend BioJewel here
As far as what I heard, as far as what I heard was that the apparatus was in a hermetically sealed container, so it wouldn't be affected by anything going on the outside.
Is there pressure
And he
inside
used
that
different-
container? Is there pressure inside, Babs?
Yeah, there would be.
Is there a gradient
not a
inside?
Probably not. No.
So there's no downward bias now in that container.
There'd be a little bit of weight towards the bottom of
Babs,
it.
you said
But
outside.
they're not measuring a downward vector. They're measuring a lateral.
No. I'm not asking about.
different-
I'm not asking about the measurement. I'm saying you're saying outside there's a downward bias, more gas gradient, but inside there is no downward bias.
That's not true.
I'm asking Babs.
I don't care. I answer.
I know
That's
what
not
you
true.
think, Paul. I know
That's
you
a
think there's
straw
a gradient
man.
inside.
You're making a straw man.
I'm not
Chemo.
arguing against your point, Paul. I know you think that.
No,
I'm saying
you're not. You're not really arguing against the point. You're making shit up.
No, I'm
You're
saying to
things
Babs,
that
does he
aren't
agree or
true.
disagree?
You're providing a straw man. You're providing a straw man as an argument. There are things that we aren't saying that you're claiming we are.
The reason that there's no gradient in that container is because you need to travel a significant distance to notice the pressure gradient in the atmosphere. You're not going to notice it at like 2 feet or 3 feet above the ground. You need to travel significantly higher above sea level to notice that.
Well, even if there is a pressure gradient, the fact that there is negated by the fact that he's using a torsion balance with balls on each end of the balance. So it doesn't matter whether there's a pressure gradient there or not, because the force he's measuring is lateral. It's not in the direction of the gradient.
That's what I said. It's a horizontal direction.
Will not the gases attract to the balls on the pendulum?
Whether they do or not, it will not affect the outcome of the experiment because that's not the direction the torsion balance is measured.
So you say?
Yeah, the gases are moving vertically and the balls are moving horizontally.
Yeah, but
two completely different vectors.
Yeah, but the gases are moving around, aren't they? Bouncing off the walls and stuff.
Yeah,
exactly. Now,
and
if we
they're
can
doing
eliminate
it equally
that,
in all directions,
if we can
right?
eliminate that
which
cause,
means that they cancel out.
Well, again, that's what you say. But what I say is, if you put it in a vacuum,
I say it because it's true.
Well, we won't know that until BioJewel, our good friend here, the new star, once he completes this experiment in a vacuum, you would either have your force or you will not. Very simple.
I don't think BioJewel is going to do a Cavendish experiment because it took Blue Marble Science almost an entire year to do that. So, is he committed to do that?
Well, he went to a couple of universities, colleges. He was denied, and then he decided to build one himself. Now he's connecting with Blue to make sure.
Did he really build a Cavendish?
He's going to do something, yeah.
Oh wow!
We already know it's unlikely you'd accept that
he's
experiment.
Working with
because
no, he's building a vacuum. He's got to put it in a vacuum. If it's not in a vacuum,
if I recall, either BioJewel or someone else posted a paper of an experiment which was in a vacuum.
Oh, let's not go through that again. We know there's papers. We know this.
Very recent, chemo. And until you can debunk or refute the mathematics in the calculations, you really don't have any grounds to talk on it. Because if you're just going to say, well, that's just mathematics, that's not good enough. You've got to show why that mathematics is invalid. And until then, stay out of the fucking pool.
We don't deal with your pseudo numbers. What we deal with is the practical nature where we can
there you go. The same pseudo numbers that you can't even refute.
So hold on, look,
you can't call them pseudo until you prove that
we are detracting from Babs. Babs, now
no, we are keeping you in the fire is what we're doing.
Babs, you were saying Cavendish, okay? So you still think mass attracts mass at this point?
Yeah.
But without an experiment to show it.
I cited Cavendish, and I know that there's problems with mass attracting mass on flat Earth because on the globe model, the mass attracting mass is based on the center of gravity. And on flat Earth, if there was a center of gravity, all the vectors would be different. They'd all be pointed towards that center. But if we were living on an infinite plane, that would be different.
So, can you show me Cavendish then, Babs, in a vacuum?
I can't, no.
Well, Foucault's pendulum would work pretty different on a flat Earth
Babs,
as well.
In the real world, I just have to believe this idea.
Well, no, I mean, but you have to have a reasonable standard of evidence. If someone shows you a well-controlled demonstration of the Cavendish, apparatus demonstrating an attraction between masses, to deny that is a demonstration of attraction of masses, I think is an extraordinary feat of mental gymnastics that you have to put yourself through.
No, again, if we're doing science, we have to account for all the variables that are a cause, a possible cause.
Yeah. Yes. So unless you can demonstrate how that pressure is a possible cause, then you have nothing.
What are you talking about? So the atmosphere doesn't move things around.
Will it move the torsion bar? That's what you'd have to show.
Yeah, of course it would. If you put it in a vacuum.
There's no such thing as a perfect vacuum. So even in that vacuum, you're still going to have particles of air.
Right.
No, if they can show zero, that there's no pressure, because we're talking about pressure. The pressure is what's making it move. That's the cause.
All right, I'd like to jump in here.
Because with pressure, you have a push. Pressure is push. If you put it in a place where there is push, of course it's going to move. Obviously, you put it in a vacuum where there is no push.
Sorry, chemo, but proof by obviousness is not scientific.
Well, you put it in a vacuum where there is no push. it will not move.
I'd like
And
to join
bio...
this, please. No, Chemo's afraid of letting me join.
I'm
You don't
not
have
afraid.
to argue about it. You
I'm not
can
afraid. I'm
simply
listening.
ask-
I'm listening.
You can
Chemo?
show it.
Okay, so the basic premise is when blue takes the weights away from the outside, the pendulum comes to rest, thereby dispelling any theory that wind or hypothesis that wind inside the container
Sure.
is causing the motion.
Sure. But again, that is part of your hypothesis, and we will never, ever, ever, never know this until BioDuel...
Actually, yeah,
That's part of the
that is a good
demonstration.
point, though. Yeah, how can you demonstrate that it
Is
is?
my mic not working?
Can you demonstrate that it
Yours
is
is working,
air
Kurt.
pressure that's causing that to happen, Chemo?
Right,
Absolutely.
Like Chemo, if you're gonna claim that it's that, then where's your experiment where you show that this is the case?
How many times should we go through this? I don't mind. So, we've got a paper, okay? And on that paper, it says there is a Cavendish in a vacuum. Now, obviously, if there was Cavendish in a vacuum, we would have that observation to see, but we don't. So that's my supporting evidence, is that we just have a paper, and we know what papers are
No,
worth.
we're talking about blues and the
That's
effect of
not
weight on it.
showing proof of anything. That's an absence of evidence, which you seem to always conflate as an evidence of something.
Yeah.
Okay, wait.
And you
hang
can't
on.
even read the first fucking page on that paper, Chemo. And if you say you can, I'm going to get you a formula, and you're going to decode it for us live. You game? Are you game?
No. Again, we're just looking for
Oh, no,
mass...
you're not game. You're not game. So you're not able to show where the math is just pseudoscience, right?
Wait, Chemo, I have another demonstration I want to present to Chemo.
Okay.
So we know that density is mass per unit of volume, right?
Okay.
That's what density is, or mass over volume. So if we take two objects that have the same density, same mass per unit of volume, but they have different volumes, we notice that the larger object exerts more pressure. So if it was only density that was causing things to move in a downward vector, why don't they exert the same pressure? Why is it that there's something secondary that's causing that force? If you understand what I mean.
Well, this is where it would be relative, right?
Relative to what, though?
The medium that it's in.
No, but my question is, if both of these objects are the same density, why is it that one of them is exerting a larger force? If there's no secondary
how are you measuring this
factor
force?
that's attributed to that?
How are you measuring this force?
I could use a scale.
With a scale.
What, you've got what, you're dropping two objects onto a scale?
You're weighing them at different times. Two objects of the same density exert different forces.
How will they do
because
that?
they have different weights.
Different weights, yeah. More density, yeah.
No,
It's not
different
more,
weights,
it's the
same density.
Look at the diagram I just posted, Chemo. Both of these objects are the same density, but they're exerting different forces.
Yeah, but they're not
How is
equally.
that possible?
They're not equally balanced, though, are they?
That's the point. They have different forces.
No, if you put them.
That means that weight is part of that equation.
No,
It's
this
not
is
just
this is an equilibrium here now. Yes, if you take it out of disequilibrium, yes.
Chemo, which way is more,
that
Chemo?
picture there, Babs, is equilibrium. That's what we've got here.
Yeah, they're
they are
balanced, but they're the same density.
Balanced.
Which weighs more, Chemo? A large ball that has a density of 4 kilograms per meter cubed, or a larger ball that also has a density of 4 kilograms
What
per
we're
meter
looking
cubed?
for, again, is a way of demonstrating the atmosphere has pressure.
No, what we're looking for is you to answer a question that was presented to you.
So Babs is
Running away
invoking
now,
there's a
Chemo.
force.
Yeah.
How are we going to demonstrate
be.
that force and show that it's not something else?
Chemo's the Nadia Comaneci of mental gymnastics.
I tried to demonstrate it with a gas experiment, but I can't think of any other way to demonstrate it. I would say the atmosphere, but you don't accept that either.
No, but what did you really demonstrate it with your experiment, or did you have two or did you have two surfaces? Give us the pressure.
Chemo, you would know the answer to that question if you actually watched it.
Hey,
Did you watch it,
Babs,
Chemo?
I did watch it.
there's a
He poured it in
PDF.
on top of the scales. The scales went up a little bit, and I expect that because you have two surfaces.
Right. What were you gonna say, Sheeple?
I was saying I posted a PDF there. I don't know if you're allowed to get it. Just get it. before
yeah,
it
there.
disappears.
Yeah, I see it. Yeah.
Now,
Is this the really recent? Wait, no.
Are you
there
being
was one where
serious,
they.
Babs, about this force? You can't be serious.
I was talking. But anyway,
I don't think you're being serious.
Even Brandon said the same thing, that I wasn't being serious, but I am totally being serious.
I don't think
just
you're
because
being
I think gravity is a thing doesn't make me a glober.
You're not being serious. I can't believe. I think you're just doing like a test, or just questioning.
I'm not doing a test. Like, I honestly have tried to understand why there's a pressure gradient in the atmosphere, and I logically come to any other conclusion.
The saddest fact that I see here, the saddest fact that I see here is that Space Pope is being honest and asking questions and trying to get to the truth.
How
and it
can you
seems like
have
the
this
flat Earth
gradient?
community
You
is
haven't
gatekeeping him
explained.
out of it because
Does the atmosphere get
That's
thinner
really
and thinner
sad.
and thinner into space?
I don't believe in space.
So what happens if it gets thinner and thinner? Does it get thinner and thinner to the moon, to the sun? Or does it stop the atmosphere? What's going on?
I haven't been to those different altitudes, so I don't know.
So how are you making this claim then that it gets thinner and thinner?
I'm just basing this off of what we've observed in the troposphere.
What have we observed? Show me. What did we observe?
We've observed that there's higher pressure at sea level than there is at higher.
How did we observe that?
We measured it with barometers.
Which requires gravity.
Not necessarily. If you're using like an aneroid barometer, I think it measures kinetic energy, and that has nothing to do with gravity. That's just measuring the amount of particles in the air.
Kinetic energy as in fairy tale.
Who is this guy?
That's Thon. Thon, he's 65, so...
yeah. I'm not going to answer that.
And does that mean that I'm more educated? Been around?
Yeah, it means you're wise, you know your stuff, right, I guess?
Oh, I'm not wise. No. I never...
Thon here, Thon. He's 65, he's wise, he's seen things, he knows things.
Right.
Anyway,
that's a conman.
Spacebro, I don't know if you got that PDF, but if you did,
could you post it again? Someone just took it away. You're gonna need to post it again.
I'll send it to you directly. But the
just DM it to me.
Yeah, I don't know if I'm allowed to share it publicly. I thought it was a public paper, but anyway, the point is that I just want you to be, when I looked at this paper, I could see what they were getting at, but I could see how in depth it was, right? And the idea of refuting something is fine, as you know, but it's kind of in your lane type stuff. So I just want you to open it up, scroll through it, and say yes or no. Can I understand what's being said here to the fullest extent, including all the formulas and all the rest of it? And do I have the capability to just refute it offhand?
Okay.
Because chemo will and call it pseudoscience, but there's
hold on, let me
clearly
ask Babs.
not the case.
So Babs, if gravity is a thing, that means the heliocentral model works. That means everything that they describe is as they tell us, because all they require is that force of gravity.
Correct. But that doesn't make it a reality, though. Just because something can be modeled doesn't make it factual.
But you've got no reason to doubt it, is what I mean.
All right. Okay,
I
so
do.
when I
flat earther, I still doubt the globe. So.
How can you possibly doubt it when gravity explains everything that you need to know?
It's true, chemo. It is the glue.
I'm using logic and reasoning to come to a conclusion.
Babs, how
Right.
can
So,
you
chemo,
say...
when I climb the mountain, why is it harder to breathe?
What PDF are we looking for?
I can't see how you can doubt the globe and doubt the heliocentral model.
I do doubt the globe. I do, honestly.
What do you doubt about it?
What is my doubt about it? I just don't think that we live on a globe. I mean, I've been trying to... Every time I try and convince myself that we do, I just feel like I'm lying to myself. Yeah, and that's me being honest.
What's the reason that you can't be... What doesn't work?
What doesn't work for me? I feel like the images look a little bit sketchy. The images we get from space and the images of Earth look kind of weird to me. And I know that there's the issues with the cameras and the focal length or whatever.
But we knew it was a globe. We knew
still
it was a
looks
globe before
weird to
that, though, Babs. Before that, we knew it was a globe. Before the pictures.
See, Chemo, you're just a Poe,
I,
aren't you?
I don't think it's a globe, Chemo. I don't
Yeah,
know
but
why
I'm
you think
saying to
that.
you, have no. I can't see your doubt. If gravity is a force, then everything should work how they tell us.
Why can't gravity work on flat Earth though?
You don't need a force.
Because it would turn it into a ball.
You do need a force to have a pressure gradient in the atmosphere.
But why would there be a gradient? Well, again, if it's the flat Earth, is it space above the flat Earth?
It's a lower pressure system.
Then what?
You don't
Then
believe in space, but what's the rest you see?
I don't know. I haven't been up there to confirm it or verify it.
No, but
That's why
if you take a
photos look
picture,
sketchy to me.
if you take a picture in the night sky, yeah, and you clearly have something on your fucking picture, right? What is that?
Yeah, I'm just taking a picture of the night sky.
Okay, and do the same thing and have an exposure time of 2 minutes. Then all of a sudden your picture has a lot more in it. What's that? Where it comes from?
So you're saying that we can't have stuff above us on a flat Earth? That's only possible on a globe?
No, I'm talking about space, about the Earth.
Right, and I'm saying that I don't think space exists.
Yeah, so that's why I'm asking, then what is it that you can see?
So when you go outside and look into the sky, you see outer space. Is that what
Yeah.
you're telling me?
Yeah, you
'Cause
see
it
outer
doesn't
Milky
look,
Way.
it doesn't look anything like the images that we get
Well-
shown of outer
Well,
space.
that's the Milky Way.
Right.
If you take a picture with a Nokia, like the first Nokia telephone, right? With the first picture you took there from, it's like, I don't know, 20p or something. And then you make a new one with your new phone. And all of a sudden, hey, it's way better. Doesn't that explain something?
No, it really doesn't. It just means that you're using a higher megapixel camera with better resolution. It doesn't prove outer space.
It lets more light in.
Pictures
well.
you get from it. If you take a picture of 1 second or 2 minutes, you have a totally different picture with way more stuff in it the longer the exposure time is.
Are you talking about star rotations? Is
No,
that
just
no.
exposure time.
So
Means the
why would
lens-
that not be possible on a planar Earth? Is my question, because you're trying to invoke the globe by saying that when we look up.
No. You deny space. I just want to talk about space. Why do you think it's fake? And if I make a picture just with a second, or I make an exposure of 2 minutes, I get way more stuff in my picture.
Okay, so that means space exists.
Well, to me it does, because hey, I can see a nebula when I take a picture of a second, but I can see a nebula when I have an exposure time of 2 minutes.
Well, that just means the solar system exists, not different galaxies and all that weird stuff they show us.
Yeah, it does.
The thing is,
because you can also make an exposure time of like 2 to 4 or 6 hours, and you get way farther and farther and farther. That's the science behind it. That's how it works. That's how they know.
Yeah, and they also put the Hubble isn't not on Earth, is it? It's far away from Earth, so it's through a whole lot of atmosphere and everything that we take photos. That doesn't exist for it, so it can sit there in one position.
You don't need Hubble. You don't need the Hubble.
No,
for
I'm
the
just saying I'm just referring to the first thing it doesn't look like we see in the pictures is because the thing that took those was dedicated and it was not on the planet. And so it was able to take long exposure photos purely for that reason. It can't take close things. It takes distance stuff.
Right.
So
I just don't see that as compelling evidence for space. I look at the sky and I just see the sky. I don't see outer space. You guys choose to call it space. I just call it the sky.
But what is it then?
Yeah, but
Is
your
it
eyes
fake?
can't see everything. That's the whole problem.
The stars, though, that we what
No,
are they?
Give it to them. It's just called sky all the way up throughout the Milky Way and every other galaxy that exists. Call that sky all you want, man.
Yeah,
right. Do you see galaxies when you look up into the sky? Do you see that?
Not with your own eyes, no. You need fucking stuff to do that.
We're in a galaxy.
Even a crappy telescope that's like $100, you could see Andromeda, and you could clearly see that it is a cluster of billions of stars. It's 6 times as large as the moon.
You need to believe in space, then go for it.
No,
man.
you need to
No,
believe
that
in
has nothing to do
anything.
with
You just
belief. You
need
believe
a
in God. That's what you
telescope.
have to believe. Space is there and it's real, you know?
Well, I personally don't like believing in things. I like having things proven to me. If you have
I'm
enough-
just curious.
Look.
What is this? What is okay? Take the sky during the day. That's fine. Sky, got it. But at nighttime, your constellations, those things you see in the sky are there. You say they're there. If they're not what we say they are, vast distances, light that's reaching, visible light that's reaching our eyes.
Mm-hmm.
What is it?
I never said they're not what they say they are, but I
Okay.
mean, as far as those stars being suns, that is a possibility. But as far
they
as
know that. They know that it's not. They think it. It's they know it. That's the
they know
problem.
that they're suns. Okay.
Yeah, they know that.
Every
Right.
star is the sun. But the thing is that you know how like let's take the P900. Zoom in on a boat, right, on the water. Zoom in, and depending on where that boat is, you can zoom right up to that boat. But when we point to the sky and we zoom in, we can never zoom in on these stars. That tells us that they're not even at the length of the zoom at any range. So does that not tell you that they're very far away?
It does, and you actually brought up a good point because a lot of globers use that example. They say that because we can see these really, really far distances using telescopes, that means that on Earth, on the terrestrial plane, we should be able to see infinitely. But they negate the fact that we're looking through a thicker layer of atmosphere, as opposed to if you're looking vertically or diagonally, because just like we said before, there's a pressure gradient in the atmosphere. So if you're looking upward, you're looking through less atmosphere. So you should be able to see more.
You could see
Yeah,
the
but if
stars
the-
on the horizon just as well as you could see them up in the sky.
Not really, no.
Yes.
Actually, some of the stars kind of slow down when they get closer to the horizon because of
No,
the
they-
fraction.
If you follow a star, its speed will not change because it's not dependent on the atmosphere in any way. Saying it doesn't make it true.
I've never seen stars on the horizon, ever.
Do you live near towns that are hundreds of thousands of people?
Actually, no. I live in a big city, so it's kind of hard to do those type of.
Yeah, you've got
observations.
light pollution, I think.
So it's very simple. I highly doubt that a 100-mile journey in whatever direction you need to go would be still in a city. Even 30 miles, that's a long distance. Just travel outside of your town and look opposite of that town at the horizon, and you'll see it. And you'll
Right.
clearly see it.
I'll give you that. I haven't done that observation, but how we can verify that space is real just by looking up at the sky. We don't have to necessarily go there or travel there. All we have to do is just look up and declare that, oh, we're looking at space.
Well, we're looking at the sky and that space, but it's to say outer space, deep space. No,
no,
I don't think the distances allow that. But if you did have like a really dark, like the dark sky and a camera equipment that could take very long exposures, and you never move the tripod, it would, and you put it all together, you would see many smaller points of light. Astrophotography is amazing. Colors that your eyes can't see directly are captured within these exposures, and that's all there. You know what I mean?
Yeah,
And so,
I agree. I agree 100%. And yeah, all the people doing that are not lying to us. I totally agree. And to touch on what Kimo was saying about me, he can't see how I can still be a flat earther and believe in gravity. I like to form logical conclusions. And I mean, I've gotten a lot of flack for my position, but still, I mean, I'm just going to follow logic. And it just logically makes sense that there is a force that causes things to fall down. I can't see it any other way. And to say that I'm not flat Earth because of that, I mean, I just don't get it, man.
Yeah, you're just threatening his whole argument and position. That's all. But here's the thing: things don't also only fall down, do they? They accelerate down.
Yeah, they accelerate down. Yeah.
You know, and so if something was just falling down in its medium, it would be more of a uniform fall, right? There's no reason why, if it's just falling through a medium or a denser medium, which is lower than drop it from the top of a second story or something, right? It's dropping into a denser medium, so it should be theoretically slowing down based on the relative density argument. But instead, it speeds up through that medium, doesn't it? So it's constantly accelerating, and the constantly accelerating, I think, is a definitive proof of a force.
Right, and that's why I gave the example with the two objects that were the same density. That kind of demonstrates that there is a force. Because those two objects, if we were to take them and drop them off of a building, you notice that the larger one would fall faster, right?
What if you what if you changed?
I wasn't there for that part of the argument, but I agree with exactly what you just said.
What if you change the medium?
Go ahead, Kimo. I didn't hear that. Go ahead.
What if you change the medium with your experiment?
If we change the medium,
you get the same effect.
It depends what you change it to. That's pretty vague.
The medium.
Yeah, you need to provide a little bit more information.
Well, we're looking at cause and effect. You're saying there's a force that's causing this.
You're really low, mate.
Remember, we have to ensure that the force is causing this by manipulating it, right?
Okay.
So how are we going to show that it's the force and not something else?
Okay, so the dependent variable, that's the cause. No, that's the effect, right? The dependent variable is the effect, and the independent variable is the cause. So in this case, the dependent variable is...
What did you see in nature that caused you to ask this?
Hang on, Kimo. In this demonstration, the dependent variable is weight, and the independent variable would be volume.
No, it's not your weight. Thing falling, that's your effect, yeah? Things fall, that's the effect.
Isn't the dependent variable the cause, though?
No, dependent variable is the effect.
It's the effect. Yeah, sorry, I got it backwards, and that's what I said initially. The dependent variable is the effect.
So what effect did you see?
We're observing
what was the effect?
Weight. The effect was weight.
That's not an observed phenomenon.
Really, you don't observe weight in reality?
In nature, where do you observe weight in nature?
Everything is made of matter, so everything has weight.
I know, but where do you observe weight in nature?
That's an intrinsic property of nature. Everything that has matter has weight. If I take a rock and put it on a scale, it's going to measure something because it's made of matter. It has weight.
In this medium, yes. What if you change the medium?
The same thing will still happen.
What if you put a rock? So if you put a scale underwater and put a rock on it, you'll get what?
Oh, I see what you're saying. Yeah.
Remember,
so if that scale is water, isn't that scale also going to measure something?
Yeah, the water.
Yeah, it's going to measure the weight of water. There you go.
It measures the air too, but if you put it in a vacuum, it won't measure the air. There's gravity pushing everything down, including the air and the water and the rock. So yes, changing the medium would change the weight of the entire system. It's not like you put a rock on a weight and it's like, I'm going to measure this weight of this rock only. They're calibrated to be in a specific medium, so it's not thrown off. So if you were to get a scale and put it at the bottom of the ocean and calibrate it to 0 and then put the rock down, it'll measure the same. Same thing if you put a scale in the middle of the air and you calibrate it to 0 and put that rock down, it'll measure the same. Okay? Kimo, do you understand that?
But again, we're looking at cause and effect. So Babs is saying here, his cause is the force, and
The cause was the volume.
Cause was the volume of what?
Yeah.
Of what?
Those two objects that are the same density, when we alter their volumes, we notice a difference in weight.
Yeah, but we're talking about in nature. What's your observed phenomenon?
That is in nature.
What did you see in nature?
I took two rocks that were the same density but different sizes, and I noticed that they weighed different.
Ah, so we know the cause was you.
How is the cause me? I didn't make those rocks.
You interfered with it. What did you see in nature that caused you to ask the question?
Oh my God.
I noticed that things have a tendency to be on the ground rather than floating in the air.
But things do float in the air, like clouds, balloons, smoke, volcanic smoke. Have you not been around?
That's
Yeah,
all
but-
irrelevant.
But there's a hierarchy to that arrangement. The clouds are less dense than...
Whoa, hold on. You first said things fall, and then now, after a bit more research, you realise not everything falls. Hmm?
Well, if the clouds weren't falling, then why aren't they not continuously moving upward?
Some
Why
clouds
are they
can go
staying
higher.
in fixed position?
Well, it depends, doesn't it? You can have clouds above Mount Everest. You can have clouds above just trees. It just depends, right? But not everything is going down, right?
Right, and those same clouds also have weight. If you look at the bottom of a cloud, you'd notice that it's flat. It looks like it's resting on something. So that just proves that it has weight, and it's pushing against the thicker layer of atmosphere. It's being supported by the buoyancy in the atmosphere.
Yeah, but all that was based on it just looks like, so that must mean, you said. Again, no experiment.
No,
to test-
it's measurable. It's measurable.
Yeah,
If
I
you
know that, but
heated
I'm
up
just trying
that
to say to
area, it
Babs
would fall down.
That if we have a force, we must be able to test that force.
We do. We can.
We can.
But what
When
you
I
need
was-
to understand, what you need to explain, Kimo, is why if I throw anything a minimum of a foot in the air, but let's say I throw it 6-8 foot in the air and watch it, you've got to explain why it accelerates.
Look, I know you think there's a force. I'm talking to Babs here, who
No, but
is
you've
slightly
got to
confused.
explain, and Bab agrees with me. So you've got to explain why we both agree, even though he's still a flat earther and I believe in the globe, why it accelerates.
Acceleration requires a force, right?
Why does it accelerate then?
The gases,
No, the object you threw.
because you threw it.
No.
Yeah, but mass times acceleration is force, Chemo. So why is that happening in your epistemology?
I wouldn't worry about too much about the calculations.
So here we go, Kimo. Simple. I throw it up in the
Calculations
air.
can come
It reaches
afterwards.
its maximum height before it starts going the other way, which is down, relative to my position. As it's going down, it's accelerating. Why and what, if not a
Yeah, but the
force, is accelerating
there
it?
is no acceleration of 9.8 meters per second, so it's different.
Yes, there is.
Decelerate.
We watch it accelerate.
Yes, at different rates.
Different mass.
No, everything accelerates at that speed.
No, it does
long as
not.
it's at the same place.
If
you
things
go to a
accelerated at
different
9.8 meters per second, again, you may have something, but there was no evidence to support this wild claim, Babs.
Yes, there is. Go on top of your house and drop a ball and measure the time it takes to get down there.
Babs.
And then, because you want to be accurate, you want to do this as many times as you can. Do it like 100,
Babs.
150 times.
You're saying Babs.
Yeah, I'm still here.
You're not going to
Babs.
listen to me, Chemo?
Babs, you're saying
You're
there's
not
a
gonna
force.
listen to me, Chemo?
Babs, you're
Hold on
saying
this
there's...
point, Mike. Don't let him get
Because,
away.
Mike, you only want to talk when I'm only talking. Whenever I try
No,
to...
I was already talking and you interrupted
No, I
because
don't
you
mean
know
that.
that if you were to
I
do
don't
this
mean
experiment,
that.
you would be
I
crushed.
don't mean that. I mean, when I ask you to engage, okay, you only want to have fun, you want to play around and talk about nonsense.
No, you're thinking it's nonsense because you're not even letting me talk.
Oh, excuse me a minute.
You can see
Back in a minute.
acceleration. Oh, Jesus Christ.
He's a test, Mike. You just need to get past it.
It's a really easy test that you could do. Like, any 5th grader can do this. All they need is a stopwatch. And if you only do it once, you might get varying answers. That's why you want to do it many, many times. Especially if it can reach terminal velocity, because it's going to meet terminal velocity at the same time every time. So the only thing you'd be measuring is that acceleration. So that's the higher you go to a point is the best.
I don't understand how a 5th grader can do this experiment. It's a very complicated experiment.
Yeah, dropping something and taking measurements and then figuring out with just simple basic math.
Yeah, but how are you going to figure out? First of all, you got to have like extremely precise. If you want to figure out when it's going to hit terminal velocity.
No. You don't need any of that. You don't need any of that. His claim is simply saying that there is no acceleration. So to find out that there is an acceleration, you can be a 5th grader and not have unbelievably precise measurements.
You'd also need to take into consideration you'd also need to take into consideration the shape of the objects that you're dropping. If I'm dropping like a flat sheet of metal and a bowling ball, they both have different aerodynamic qualities. So
right. It would be the same type of object, the same bowling ball. Give it to 100 children. They all take their measurements. That would give you an average, a mean of the entire fallings. Mean time it takes to get down there is this. That's why you want to drop as many as you can. Obviously, if you start changing the variables in massive ways, of course you're going to come up with different answers. That's completely
the same material, just with different drag coefficients. And then you can use different materials with the same drag coefficient, and then you can demonstrate objects of different mass fall at the same fucking speed and gravity.
Exactly. And yeah, so that would actually show that all shapes have the same force on them. But just to find the force, you would just use the same ball falling over and over.
Kosho tried to explain this to me a couple months ago, and I didn't get it. Because if you drop 2 objects that are different sizes, they're going to hit the ground at different times. But you guys say that they accelerate at the same rate. If they were, wouldn't they hit the ground at the same time?
If there was no other drag. One second, Milk, I can do this really easy. You brought it up, Space Pope, brilliantly. Because you said there's a difference to a dart falling to a sheet of metal falling. Even though both of those things are made out of metal, the sheet of metal is going to fall in a very different manner to the dart made out of metal. We both agree on that, yeah?
Yeah, because it has a larger surface area, so it's going to create more friction.
Exactly all we're talking about. The surface area that is presented to the wind as it's falling downwards.
Foolish. If you say you have 2 identical dots falling, and
one's hit the ground at different times,
and one's not, that's going to make a difference too.
Yeah, like if we took 2 objects that had the same drag coefficient, like say a ball bearing and like a bowling ball. The bowling ball is going to hit the ground faster, though.
No, it won't.
It won't.
No.
They're going to hit the ground
as long as the drag coefficient is the same, they will not.
Right, but if you get, let's say, a plastic dart and a metal dart, they're the same shape and the same size, that doesn't mean their drag coefficient will be equal.
Ben.
Oh, it won't, because mass is part of the calculation of drag.
Exactly. So you can't use the example of plastic dart, metal dart, because that would change the drag coefficient. And whenever you're talking about dropping something here on Earth, everything falls at the exact same way, and the only thing that matters is the drag coefficient, or maybe a heavy wind on one where no wind's on the other.
Mass matters. We just said the mass matters.
The fact is that it accelerates visibly no matter what we do. In fact, we accelerate when we trip and fall. That's why it fucking hurts.
Coefficient would be the same. Drag coefficient would be the same, but the force that's projected because of drag coefficient opposite to gravity is dependent on the mass of the object.
Yeah, okay, but do things accelerate when they're falling?
Obviously,
yeah.
If something
No. I'm just asking Branch.
If something initiates a fall, so if it goes still to falling, it has to have accelerated. It went from 0 velocity to 8 velocity.
Okay, let's say I get a golf ball and I roll it off a 2-story roof.
Right.
And it gets to the edge of the roof, it begins. It's no longer. There's nothing under it anymore. It stops rolling. Is that golf ball going to continue to accelerate down to the ground? Yes or no?
It's gonna start accelerating. It never was.
No, when it rolls off the edge,
Until
and
it
there's nothing more underneath it. It's not
Till it
physically
left the
touching the
cliff.
surface.
Till it left
It
the cliff,
accelerates.
it wasn't accelerating downwards at all. The moment it left the cliff is when it started accelerating.
Right, so it accelerates as it's falling, right? So you agree, Babs agrees, Mike agrees, Josh
Acceleration is
agrees, I agree, but Chemo doesn't seem to agree.
Oh, then
So
I
that's
agree with
denial, everybody.
What I
That's denial on
Then I
display.
agree what I said, and I agree with whatever the fuck Chemo said.
Yeah, but it's denial on display. He's literally hitting a mental wall which he won't pass. He won't allow himself to pass.
Even though a lot of you guys he simply presented your question to Chemo incorrectly.
Even though a lot of you guys agree with
now
my
in Chemo's
position
mouth.
is on the whole gravity thing,
trying
the
to
flat
put
earthers
words-
are not going to accept that position, though, regardless of the amount of fact that's presented. And I don't understand why. It's almost like when you accept that concept, it makes the globe a reality. But why does that matter, though?
The only thing Chemo's trying to say is there's other reasons why something can move downwards other than gravity.
Exactly.
He's right.
Exactly. And that's what we're trying to establish, Branch. If it's not what we say it is, what is it? And don't
Right.
replace it with the same properties that gravity has. And
Right. Density is one of the reasons things move downward, but it's not the only reason.
Yeah, I'll give you that. It's not the only reason.
But gravity
But
is just a label that we've given to the observation that things accelerate towards mass. So the label, by definition, being subjective, is correct because that's what we've labeled that observation.
Yeah.
So
Exactly.
calling it something different is just stupid.
Exactly, Josh. And you've seen them try to do that. They take the properties of gravity and just say, well, it's not gravity, but it does all the things that gravity does, but it's not gravity.
You guys are
So
saying
we've had a crash in the past, and that's cool, but keep an open mind. Keep asking the questions. The fact that flat earthers can't get to where you are is because they've stopped looking for answers. So I commend you on being able to agree and also hold your own opinion. It's very rare.
I don't have any personal issues with you, even though we have clashed in the past. And I mean, I understand what your frustration is. A lot of people are just willing to throw a lot of stuff out the window. And I get it. I mean, I'm not like that. I don't personally get offended by anything, but some people do. And I completely understand.
Hey, Space Pope. I've got a little thought experiment for you. Imagine space is real, just for a second, okay? Imagine space is real, and you have a sheet of water that's like an inch thick, and it's pretty large. Let's say it's the size of your living room that you're in right now, and it's an inch thick, and it's in space, and you believe in gravity. What shape would that flat plane form to naturally? Do you know what gravity would say what shape it should be?
If everything is attracted to the center of mass, then it would be spherical.
Okay, so now imagine that same concept, but a gaseous cloud where gravity is being pulled in towards the center. Don't you think that it would have a very large center and the possibility of having planets that are also spherical form on the outer layer, moving closer and closer towards the center?
Yeah, that is a possibility. But
Right.
your example was only using one substance, and the Earth is made up of so many different substances. So in order for gravity to need to have
it started as a gaseous cloud. So its substances, in my opinion, would be a moot point. You know, whether we just have one specific molecule, let's just go ahead and say it's, you know, iron, and all this massive gas cloud is tiny little bits of iron. Those tiny little bits of iron would form a sphere. Whether it's water, it would form a sphere. Whether it's water and gold and iron, it would form a sphere. So at that point, why is it such a stretch of the imagination to just say it seems likely that it would be a spherical planet rather than a plane planet?
Well, it's not unlikely, but there's something wrong with your example. If we take a homogeneous gas, what would what would its center of mass be?
Well, so
It doesn't have a center of mass, does it?
yeah, it would, because every little particle is causing gravity. It is forming the curvature of space-time, and
But they're all attracted to each other. They're not attracted
no,
to
that's not how that works. That would work with like the electromagnetic force or the strong or weak force, because their distances that their strength travels is very small, and it doesn't go any further. Even if there's a bunch of it in one spot, it doesn't stretch out. Gravity is forever. So if you have 2 points in the middle, a little bit closer to one another, that gravitational pull is added on top of each other, causing the outskirts to have less gravity attraction towards it, and the deeper into the center, you would have more and more, because everything in one direction is being pulled towards all of it. What behind you, there's nothing behind you, but there's a bunch of stuff in front of you. The stuff on the outside would tend to go towards the middle. Now, the stuff in the middle would still stay in the middle, because the stuff behind it's being pulled towards. I'm being pulled back, I'm being pulled forward, left, right, up, down. So the stuff in the middle would kind of stay stationary, not legitimately stationary, but for the concept of this conversation, it would stay pretty much stationary.
So all it would take is two gas molecules attracted to each other to start the whole chain reaction process, is what you're saying.
Well, yeah, but again, that's really finite thinking. All of them are putting curvature into space-time. So you can't really just say it's just those two. It's literally all of them all at once.
Yeah, that's the part that I don't understand. If they're all at once equally attracted to each other, why would there be a center?
Yeah, no, I got you. I think I could figure this out. Let's just look at a two-dimensional plane concept of a three-dimensional idea. Put a bunch of dots on a piece of paper, and then individually look at one dot and say, where would I travel if all of these had the same gravitational pull towards everyone? If you are in the center, that's going to be pulled in some direction, but it's not going to be really dramatic in that direction because it's all around it. But if you look on the outskirts, you don't have anything off of the outside of the piece of paper, so it's not going to be pulled that direction. It's only going to be pulled towards the center. So if you were to...
So in that case, it would form a gas cloud. It wouldn't form a sphere. It would form a gas cloud.
Hate to interrupt, guys. But you guys are forgetting one thing: spacity.
What's spacity?
Many times, spacity explains it all.
Troll.
But yeah, this was a really nice conversation, but I had to go like minutes ago. I'll talk to you guys later.
Just do me a favor and just think about one of those particles and where it would travel. Just, I'm here in this glass cloud, where would I go? Whether I'm in the center or on the outskirts, where do you think it would go?
Yeah, I'm gonna have to sit on that for a little bit, but I'll think about it.
Yep, have a good one.
See you, mate.
Mike, I think Mike, you bring up great points, Mike, but why, like, when we talk about all the other planets, right? And if you're considering how the other planets were formed, I agree that, you know, a self, all forces would equate to something becoming a sphere, because it's the most natural object. It has an equal bound if you have a central force, right?
I don't know if you guys noticed that this method is very aggressive, even towards local, familiar faces, people.
Chemo.
It doesn't you know, look at the person. It looks at what
Chemo.
And
I was trying to make a point, Chemo.
Chemo doesn't care. Chemo's gonna come in and talk his talk, walk his walk, write his script, no matter what.
Dude.
That's why we need Rizzler as a mod.
Yeah.
I don't know
Anyways,
that. I've never.
so what I was trying to say is,
anything nice.
I understand, Mike, what you're saying about the other planets, but you gotta understand that we're very unique on Earth because we have a dome.
So I'm not. No. Okay. I don't want to have this conversation. There's no evidence of a dome in any way whatsoever, at all. And to sit here and say that the laws of physics outside of Earth will obviously make a spherical planet, but for some reason a spherical planet on Earth is just so far-fetched. I'm sorry, and this is going to sound narcissistic and rude, but anyone who truly thinks that is beneath me. And I'm not going to waste my time anymore having conversations with people that are such simpletons that they truly believe that. Okay, that is a path that you need to go on your own and figure it out on your own. I do not care whether you have.
Never want you beneath me, bro.
Right, hold on, Branch. You're not even a flat earther or a globe earther, so you're just wasting time for the real flat earthers who need to address this point. Okay.
Exactly, Kimo. You need to get back and answer why things accelerate. You went away. You went awfully quiet.
No,
So
I had
Mike,
a phone call. I had to go.
can you?
But
Okay,
yeah,
Mike.
now we're back.
You're much better at this than me.
Yeah,
With great
Branch,
examples.
sorry, it's not personal. It's again, you know, you're here for fun and
Very
entertainment.
personal.
Ask him why things accelerate.
Things
and hold him to the
accelerate
fire.
require a force.
Very hurt right.
Require a force.
I'm very hurt right now. Very hurt.
Without the force, we don't have acceleration. Yes.
I'm about to
But
go
in
back to
this-
being
in
a
this
fucking
case,
globe
in this
now,
instance,
bro.
with relative density, have acceleration without a force.
But relative
Yeah,
density
then,
is outrageous. If you were to fill a container up with helium compared